treaty with the strikers to demand change because of the Ellen show continuing.
Let's check the audio.
Strikers to demand change because of the Ellen show continuing.
Very, very good. Very good, very good. Let's check the audio. Let's check the ting. The ting and ting. Very good. Okay, so hi, I'm here. So he wants to go to X space, Twitter space, Flurfs. Flurfs are flat earthers, I think. Let's go. Let me sign in. What do I do now? Let's try this again. So what do you mean? How listen live? So I'm a listener. I can't hear anything. Is anyone saying anything? Can you hear me? 1, 2, 3. Can you hear me? Request sent. Okay. 1, 2, 1, 2. So who invited me? Mordwand. I don't see him. Mordwand. Is Mordwand here? He says join VC of what? Join VC. Oh.
Turbo,
hey.
Explain.
Hey, Slave.
So what's going on?
There is Gamma. There's a King Air.
Oh, we're
Yes.
gonna go fuck with some Flurfs. If you're that. Or you could just, if you want, you can talk to them normally. But it's a lot more fun when you play with them a little bit.
Where are you going, Sea-Line? Which server?
Flat Earth Fridays, Twitter space. Have you ever been over there, Gamma?
Hell no.
Oh. You want to?
Maybe.
I want to do it just to experience X spaces, whatever.
Oh my god, that's my favorite Discord user.
Who, me?
Mr. Slave. Yes.
Wait, who are you?
I'm your number one Ether fan. Oh my god. I can't believe I finally met you.
Wait, you're Gamma No Hack?
Absolutely. That's me, yeah. Your number one fan of your Ether cosmology. Yeah.
Really? What, you understand my ether theory?
I understand it, but that doesn't mean it's correct.
Okay, what do you mean it doesn't mean? Well, if you understand it. Okay, do you want to ask me questions about it?
Not really.
Wait, what? Why not? Like, I need. Yeah, go ahead.
I'm like a number one fan, but like the number one fan you'll never know, right?
So you don't understand it. That's why you don't believe it.
No. I'm your number. I can understand it, but not.
You can?
Uh,
Wait, what? Can you? Okay, I'll give you a pop quiz. So
Yep.
explain to me why the apple falls towards the ground.
I need your PDF. I forgot.
You need my PDF?
Yeah, I forgot. I need it. This is explained in the Etherverse. Sorry.
I
Oh,
see.
all right. I know the answer to the question. 11 kilometers per second.
That's good. What about it?
That's apparently the speed that the ether moves at, right?
Apparently. So what if it does? How is that related to the apple falling?
Negative pressure.
Okay, you're putting the puzzle pieces together. Yeah, go on. I need you to somehow move the
I
apple.
forget the lore. Okay, I'm sorry. I forget the lore.
That's why you think it might not be true. Okay. You want to take a guess how the apple falls?
I would personally say gravitation, mass attracts mass.
Okay, but there's no string, right? Newton said if you think that there's action at a distance, then you're insane. So there's no action at a distance, and there's no invisible hand pulling the apple. The Earth doesn't reach and grab the apple with an invisible hand, or does it? I don't know. So why
It would
does?
appear to.
Excuse me.
I said it would appear to. It doesn't really matter. Newton didn't really care what the mechanism of gravity was. It's just the relationship between mass and distance and the
But
force.
right, but there's a letter that he wrote. I don't remember to whom. He said, if you believe that the force of gravity is mediated through a vacuum, then you're insane and you should have your head examined. Or anyone who believes that the force of gravity is mediated by the vacuum should have his head examined. That's pretty much what he said.
I mean, it does do that. So he didn't know that. How could he have tested?
Well, he knew his theory of gravity is incomplete, which it was. It's
Not really incomplete for his time. So many predictions were made with Newtonian that proved to be true. Discovery of Neptune.
it has nothing to
Yeah,
do.
Discovery of Neptune gang in the house.
It wasn't incomplete at all for his time. Like it explained so many things about the natural world. To an like.
Yeah, but it was incomplete.
I'm wondering, would Newton have objected if he knew about electromagnetism? Because that's reaching out over the vacuum of space.
That's called begging the question. That you're taking
No,
my
that's called arguing by analogy.
Yeah,
No.
that's called asking the question.
Well, so the way I explain it is, so what you're saying is not only do we not understand gravity, but we also don't. But even worse than that, or even on top of that, we also don't understand magnetism. So it's the same.
Do we not?
It's the same question. Do you believe?
Do we not?
Well, I do, and you don't. If you don't believe in the ether, then what's your explanation?
So is the ether explaining electromagnetism?
Of course, the
Explains
ether.
everything.
Explains everything.
Yes, it's a unified field theory. Yeah.
Is ether.
Wait, are you a
Yep.
flat earther, Mr. Slade?
No, I'm not a flat earther.
Okay, so like
I'm.
you're at least somewhat reasonable.
What do you mean, somewhat? I'm completely up to date with big physics. I don't disagree with
Big P.
Yeah, I don't
Big
disagree
P.
with big physics on anything.
Except for
It's not.
conservation of momentum. And
I don't disagree in conservation of momentum. Why would I disagree in conservation of momentum?
well, you said that the ether something annihilates, and when it annihilates, the annihilation produces no energy, so mass isn't conserved in ether
Well,
matters.
well, the annihilation is the Higgs mechanism. I'm not saying anything different than big physics. I'm just reinterpreting big physics. So the interaction of the ether with any what we call massive particle is the endowment. Well, that's the energy, if you want. The explosion that takes place is the inertia, is the mass that the Higgs mechanism of the ether endows onto an electron, for example.
Okay, so the energy of the ether is transmuted into mass.
Exactly. Yeah, you could say that.
Okay, so it does conserve energy and mass.
I don't know. I mean, it's the Higgs mechanism. Whatever you want to
What do
say
you
it.
mean you don't know?
I don't know.
You're supposed to be ether god. Come
Yeah,
on.
but there's a problem with the particles of the ether. They cannot have mass because mass is the interaction of the ether with the electron or with a massive particle. What do you call a fermion? So anytime, right, the Higgs mechanism endows. Oh, wait, do both? I think bosons have mass, right? Some bosons have mass. Anyway,
You're
so
asking a lot of questions for somebody who says that they have unified field theory. But go on.
I'm sorry. I'm sorry that I don't know everything. I'm only 2 months into my physics career. Anyway,
Oh,
so any
strides.
so massive particles, the way they are endowed mass is through the Higgs mechanism. So usually the Higgs mechanism comes out of the Higgs field. But for me there is only one field. It's the unified field of ether. That's all there is. But the ether for me is composed of particles, but they cannot have what we call mass because mass is the next level up. Because the mass is an illusion that is created by the Higgs mechanism. It is a mechanism of the field. It's the interaction of a field with a part with a massive particle. So it's difficult to say that that the ether particles have mass. How can they have mass? For them to have mass, we need another layer of Higgs. We need to go. There has to be like an onion layer, a deeper onion layer of another Higgs mechanism that endows mass onto the Higgs particles. I mean the ether particles, and this it's turtles all the way down. So it's like an infinite regress. So it's difficult to define mass at the scale of the ether particles. Do you understand?
I
It's
think Ceylon understands.
it's difficult to define. It's difficult to define what we call mass and and momentum. It's difficult. I'm not saying it's impossible. I'm not saying it's not true. It is true. I don't know. I didn't look into the ether particles yet. At this point, I'm just assuming ether particles with basic attributes just in order to create the universe. At this point, I'm just putting the universe together, and everything fits together perfectly. So I have a unified theory. Like black holes work for me. I can prove a black hole directly from Galileo, and you know,
Easy.
yeah, if you, I can do it like in seconds. I
Do you
can.
have derivation of this?
I didn't write the paper yet, but I can show. I mean, it's very. I mean, I wouldn't be the first guy
Do you have a
to.
draft?
I'm gonna say I wouldn't be the first person to derive the Schwarzschild radius directly from Newton, but Newton is derivable directly from Galileo. But fine. But you want to see a video? Not mine, but I mean, I have my video where I proved black holes directly from Newton. But other people have done it. I'm not.
Ooh, that'd be interesting.
Harvey, what?
I said that'd be interesting.
Oh, sure. Here. Black.
Where
I'm gonna
there's a
search.
derivation.
Oh yeah, black hole from Newton. I'm just gonna search YouTube.
I mean, I thought you had a video.
So
I
Zap.
wanted to see yours.
I have many videos where I've done that, but it would be a big chore to find it. But here's somebody else's. I'm not even sure. I didn't watch. I don't. I mean, I don't even know if I watched this specific video. Newtonian black holes. You can watch it. You see, R equals 2gm over c squared. I mean, it's easily derivable directly from Newton. You don't need general relativity for a black hole. That's for sure. So you can ask me questions.
How do you predict the perihelion of Mercury?
I didn't. I mean, I don't contradict. I didn't study GR. My math is not up to scale, but I mean, I agree with everything special relativity says. Special relativity actually comes directly out of the ether. So special. I mean, the Lorentz transform.
Totally.
Yeah. I mean, on that I have a paper. Here's the paper.
Oh,
1 second.
Oh, it's Mr. Slave again.
Yes. What do you
Oh,
mean
lovely.
again?
Yeah. I am.
Again, as in you were here yesterday. What do you think I mean?
I don't even know where I
Oh,
am.
we got-
I didn't notice where I
Oh,
am.
Jekyll, knock the shit. Stop making fun of Mr. Slave. He's
I
my
just
friend.
I just clicked on the join button. I didn't know where.
Making fun of him. I've all I said.
well, I never.
You can make fun. I had a great time yesterday. I was laughing so hard. You
Oh, so
guys,
now you remember.
yeah. Now I remember. I didn't know where I was. I just clicked the button join that C Line sent me. C Line?
Sea Lion's been up to.
Lionheart? What's his name? C Line,
Line.
yeah, C Line. Okay.
Sea Line Prime.
Line.
Oh, that is it.
I knew he'd be behind this.
Oh, wait, you knew that he's behind me being here?
Absolutely.
How did
Yeah, I
you?
pull all the.
Okay.
Ceylon is.
Anyway, so that's the paper. That's a simple paper. I don't know. I mean, you guys completely botched it up. I mean, you mangled it. So I don't know. There's so many. Did you ruin?
Wait, what?
Oh, you didn't ruin this one. Okay, please don't ruin this
wait.
one. Don't
Jekyll, did you like? Did you
don't ruin this paper. Leave it alone.
Did you like copy paste images on there? And...
Yeah, he
Different
did.
outcome.
He ruined my other paper.
Yeah, all right.
Leave the paper alone.
Ruined it.
Actually, I didn't. That was someone else. I just enlarged the image.
Okay, can everybody fix their audio? Because some people's audio is like really loud. Oh, maybe I can fix it myself.
Just turn people up who are quiet. And then
Yeah.
turn people down who are loud.
Yeah, I didn't think of that. I'm still new to Discord. Anyway, so if you, I don't know how Zap
If
physics.
it's a guy named Dan, just turn it down.
That's true.
Okay, I don't see Dan.
That's
He-
bad.
he's not
Anyway.
in here.
Anyway, so special relativity actually works better with ether than without,
Of course.
because
Definitely-
once you assume ether, you immediately get a constant speed of light.
I mean, the paper already is using very physics terminology. It imagines a bathtub as an empty space and a rubber ducky as a green square.
What's the question?
I'm just commenting on it. I like the presentation.
Anyway, I did this really quickly. I mean, I'm
Only
most.
problem I have with it is that it's not written in Comic Sans. That's gonna kill the.
Yeah, Comic Sans. We went over this yesterday. He made no changes that we suggested.
I was
That's
knocked out. I couldn't function after talking to you guys. I just couldn't function. I was
All right,
completely
I'll make
like-
a suggestion so you can change all the font to Comic Sans. Here we go.
I'm sure you can change it. I mean, you've done everything.
Comic
You've
Sans.
destroyed the papers.
Can
So
I get
why
a
don't-
link to this? I want to see how you.
There you
destroy
go.
it.
It's in
What
text
do you-
chat.
Change the font for you.
What is
It's
Echo
in-
Chess
It's in the
Bailey?
TC attached to General VC.
Isn't that way more professional, Comic Sans?
I don't think it's
Wait, what?
common sense. It's supposed to. Isn't it songs?
Oh, my
Isn't it like
God.
French songs?
Yeah, Comic
like-
Sans.
Sans serif, no?
Because that, yeah. Commission.
Oh, you speak French?
Oui. Parlez-vous français?
Un peu. Un petit peu. Anyway, so ask me questions. So if you assume the ether, if you assume, I mean right. I mean, once you understand special relativity, you understand why the ether. There must be an ether. And if you don't, then please ask me questions.
So much better. I had to make the text a bit larger because it's hard to read when it's small.
Oh my god. Oh my god. Anyway, most of the information is in the figures or in the caricatures, as you would probably call them. You know what? We should publish the paper with sans serif and with. Let's, instead of calling them diagrams, let's call them caricatures. Anyway, but it's not straightforward. Do you have any questions? Is everybody reading the paper?
Yeah, we're all reading it.
Okay.
Yeah.
So let me know if there's any question.
Comments at the end. There's 5 things.
There's 5 things at the end.
Yeah.
Oh, jeez.
Yeah, I didn't finish the end. What's the?
Thank
what's-
my good friend Sanas, who helped me.
Yeah, I mean, he helped me. If you know Einstein's original paper, that's his conclusion. I'd like to thank this one anonymous friend that he has. That's his conclusion. It's an inside joke between
You didn't even finish the paper you're citing?
paper.
We're destroying this paper.
I didn't.
Hold
Of
up,
course-
hold up. I got a AIEX. Hold on.
Oh my god.
What's funny? Just ask me a question. Mr. Besso, did you know Einstein thanked, like, in conclusion, I wish to say that in working at the problem here.
Wait, are you looking at the document right now?
No, I'm looking at
C9?
Einstein's paper. What's the question? What did-
Unban AIEX.
Wait,
All
what?
right, hold on. I'll send you a picture of what we've done to his document. Look at this.
I see the document. You still haven't destroyed it like you did the
I know.
the
it's
other
just-
one. It's just a matter of time. I know.
Where's shit getting sent to?
I don't know. He looks like somebody attached the BMP, but here's the front face of it now.
What? Oh my god, you guys! You people are insane. Oh my god.
Okay, the first rule is don't give them editor capabilities.
I didn't. They only have they only have comments.
These are suggestions, which you.
That
should
is suggestions.
That's
yeah.
fine.
There-
As
there's-
long as I can roll it back. I hope. Can I?
No, this is all server side. It's fucked.
Really?
No, I'm joking.
Oh, okay. Oh, okay. Anyway, so
I'm trying to get Neil.
you're
I
trying to
want
get
to see his big.
Wait,
It's
you're
got
trying
Neil.
You know, it's customary, right, before you write a research paper to know what you're going to be writing about.
really, but what
Yeah, it's customary, yeah.
what's the question? Do you want to ask me a question?
Because the thing is, you want to talk about the ether, like the hard subject of the ether. You want us to read
No,
the text and add
No.
suggestions.
no,
I'm more saying that I don't think you know what you're writing.
no. The word ether doesn't specifically does not show up on this paper. I think I deleted.
Just
Let me check.
hearing you call it a paper makes me want to vomit into my mouth.
Right, the word ether doesn't show up in this paper.
Control F it 1 sec.
No, I just did. There's no ether.
Oh yeah, you're right. There's no ether.
Right, this paper has no ether. It's just a proof of Einstein's special relativity. That's all. Of the second postulate, I'm sorry. I'm just
Yeah.
so I mean whoever reads it should conclude on their own that there must be an ether. It's like an inside joke. It's like of course this is what I'd like to say, but of course I can't say it because big physics wouldn't let me.
Didn't you just tell us you didn't finish the paper?
What do you mean finish what paper? Einstein's paper? I never read it. I just read parts of it.
Jesus Christ.
My paper? It's basically finished.
Either one. I don't think you finished either one.
It's okay. I don't need to finish. I mean, like a normal person that reads this paper understands everything just from the abstract. You don't need to read more than the abstract to understand the paper.
Oh, I understand the paper, all right.
Discord philosophy right there.
Yeah. I think that's the definition of an abstract, last time I checked. Like a person from the art should be able to understand the entire paper, should be able to reproduce the paper just from the abstract.
I'd like to disagree there. Letting a person finish is generally the nice thing to do.
You can finish, but if you're from the art, you should be able to figure it out just from the abstract. That's the idea of the abstract. That's at least in patents, that's what it says. So, any questions?
Have you decided on where where you're going to be publishing? Just saw the picture. People had it.
What, you pasted a picture on it?
There's multiple.
There's a couple.
I don't see any picture. You didn't paste any pictures yet.
You gotta look at the stream. Look at Kevin's stream.
You mean join the activity with the the watch the stream? Okay.
No, that's in the park with the furry. That's good.
Oh my god. Oh my god. Oh my god, genius. Oh my god.
Good picture of Hitler, by the way. Whoever picked that one, that's
You know that he copied opera. Like he used to watch opera. Just
oh really?
yeah, he was an actor. He's like an artist.
Yeah.
He always wanted to be an artist. That's all he wanted to be. So he decided, to use
Yeah. His dreams and aspirations.
Yeah. Anyway, do you people have?
So are you saying that the genocide was just a side act?
Well, that would be my claim about every anti-Semite. I don't believe anyone who says they hate Jews. I think it's all an act.
You gotta talk to them about an Earth Awakenings. Talk to levelists, and you'll figure out pretty quickly.
Wait, what?
There's a guy called Levelist at Earth Awakenings. Talk to him about Jews. And you'll that theory.
I don't. No, so
Yeah, he'll disabuse you of that illusion very fast.
Yeah.
I don't believe. I don't believe people that claim to hate Jews. I don't believe them.
Behind the text.
You will learn the error of that.
Jeff, did you put the paragraph in like behind the text?
Yeah.
Oh, nice.
So you people you want to waste hours today, just like yesterday, and not talk about actual.
Absolutely. What do you want to talk about with your paper? Like, give me. Go on. Serious faces now, guys. Right. What do you want help with? Right. What do we need? What do we need to do to make your paper publishable?
The thing I need the most is to stress test my theory, to stress test the paper. Ask me questions.
I think the way to improve the paper for publishing is to move the cursor to the end and push down and hold the delete key.
You mean the backspace?
Jews that died in the Holocaust.
Yeah, that, or move to the start of the paper. Just hold down the delete key.
Oh, okay.
Just really way into it.
Okay, but you're not
Over it.
answering. You asked me what I want, and I told you what I want, and what you answered then has nothing to do with what I want. I told you what I want. So what I want is questions to stress test the paper and my theory. So that's what I want. Can you question me? Can you interrogate, cross me? Ask me what? Just like, stress test the theory. Why is it so difficult?
There is what mathematical I've asked like 20 times now for any derivation of any of this, and it's just like
What do you
going
mean?
nowhere. Like
What's the question?
Haven't you heard he didn't finish Einstein's paper?
Okay.
I don't disagree. I
You
don't.
didn't finish Einstein's paper?
No, I don't disagree with Einstein. I don't disagree with special relativity. This is the foundation of special relativity. This is the proof of the second postulate. If you understand, if you read
In your own words, then go on, explain it to me.
right, so I was about to say you obviously did not read Einstein's paper. So Einstein's paper begins with two assumptions, what he calls the two postulates. The first postulate is basically what Lenny Susskind says, that the laws governing the juggling are maintained whether you're in a train or off the train. So the laws of physics and Maxwell's equations, they're invariant. They hold regardless of whether you're moving or you're stationary. That's the first postulate. The second
Very good,
postulate.
very good.
The,
Yes,
sec-
carry on.
the second postulate is that the speed of light is a constant. So and then based on the assumption that the postulate that the speed of light is a constant, so Einstein derives special relativity. Fine, but I come before the second postulate and I say we can prove the second postulate instead of assuming it. Now, this doesn't modify SR, GR, quantum physics. And I'm not touching big. I'm in agreement with big physics. I'm adding one layer of foundation to big physics.
Oh my God.
Mhm.
You want to ask me
Genius.
questions? Mischievous?
I mean, you got it all there. I mean, I don't know what I could.
Are you going to ask me questions? Or are you going to waste another day?
Jekyll, I added something to the paper I think you would enjoy.
Absolutely.
I'm watching this stream. As I'm speaking.
He's just adding credit where appropriate to the philosophical underpinnings of all reality.
Mm-hmm. The second, obviously, because he's Gregory the Second.
Yeah, yeah.
Here, let me give it to you in the form of a syllogism. If a paper exists, then Gregory needs to be credited. This paper obviously exists, so therefore Gregory needs to be credited.
Genius.
Okay, anyway, so so can anyone at least repeat my theory?
Yeah, something about speed of light, constant. You want to prove both postulates of Einstein.
That's
Oh,
not my
great,
theory.
yeah.
That's not my
I
theory.
think you mean prostate, Jekyll.
Oh, sorry, the second prostate of Einstein.
Okay, guys,
That's not
guys,
my
I have an
theory.
I have an announcement that is going to be maybe more entertaining with this now that you maybe. So Alan has said that he has discovered a new equation in Newton's Principia that has been suppressed until now, and it explains the Earth is going to have 2 moons.
Where is this? Where?
On Twitter.
It's great.
For real?
For
So-
real.
I've always wanted a second moon. It'll make it more like Kerbal Space Program.
Oh, it looks
That's
like
true.
with it too.
Okay, so can anyone explain to me my ether theory.
Going by
Nazi.
the paper.
What'd you
Proof
say?
of Einstein's special relativity, second prostate by Mr. Slave. Co-authored by Game No Hack. Edited by Fligu Inspired by Adolf Hitler. In memory of the 1488 Jews that died in the Holocaust. Published on September 11th, 2001. That's how the paper begins. Do I need to read more?
Yes.
Oh,
It's a big improvement.
I think the abstract is enough.
yeah. Could you imagine somebody submitting a paper like this?
I think you should.
Honestly, I would accept all those changes just because that's a part of Discord law right there. You know, you've achieved Discord law.
I know. Anyway, so can anyone please explain to me my ether theory, please?
We're not good. We're not good. Like, look, you have a bunch of idiots in this call. You're way far ahead of us. I don't think we could help, honestly.
Okay. Does anybody here understand GR?
No, we all studied gender studies.
Yeah.
Wait, GR
I,
is not GS. GR.
I learned in gender studies in college in my gender studies degree that men can't figure out quantum fluid mechanics because they don't have periods.
There you go.
That's actually a by the way.
Funny
someone-
joke.
Does anybody
so
here
that's a
agree? Does anyone here agree with Sean Carroll that the universe has a wave function?
I don't know what that means.
I know,
What
but
would
that's
that
what he keeps saying that. So you disagree
that-
with big physics?
What would that entail, though?
I
Big
don't.
physics. That means
Okay, yeah, that's going in there too. As described in physics.
Oh my god! No, we should write a paper. The title of which is Big Physics. Like we should
Yeah.
we should
You would
analyze.
give. You are the next Einstein.
No, no.
He's the current Einstein.
No,
Yeah,
I don't view Einstein as someone to look up to. You're hurting
Why
my
are you trying to prove his postulates then?
to show that that special relativity is nonsensical.
You're trying to prove his postulates to show how it's nonsensical.
I'm
And his
proving
bias.
I'm proving the second postulate, and that shows that SR is nonsense.
Okay.
Yeah, but did you see that it's now Epstein's special relativity?
But you're
So it might- it'll be a
supposed
bit-
but you're supposed to ask me how is it nonsense?
How is it nonsense?
Because if you prove the second postulate, you're basically assuming ether. And if you assume ether, then special relativity just becomes wave mechanics, just fluid dynamics. SR is fluid dynamics. It's wave
Fluid
mechanics.
dynamics is super duper complicated, though. Just saying it's
No,
fluid dynamics.
no. It's just wave mechanics. It's not even worthy of wave mechanics. It's just waves. It's just wave analysis.
Special relativity is related to waves.
Yeah, special relativity is just a theory. It's not even a theory. It's just waves. Here, I'll give
What do
you.
you mean?
Here, I'll show you. Give me a second. Everything is on YouTube. Do you guys ever watch YouTube?
Yes, that's how I learned basics of special relativity. I didn't see anything about waves.
Okay, I'll show you. 1 second.
That's
You
why
clearly-
you got me confused.
Oh,
Clearly didn't do enough LSD. Then everything is waves.
here. Give me a second. I'll show you.
Well, in that case,
Well, in that case.
that's why I get into that.
Let me find what you need.
Bacon, did you hear what's happening on Flat Earth? Oh, you're doing not on Twitter. Damn it.
Yes. Not on Twitter. I mean, I
Alan-
am on Twitter. Twitter is not on me.
Alan is Alan is going to introduce a secret hidden equation of Newton that he has personally discovered, apparently.
Okay, so I posted in the side chat what time dilation actually is in relativity. Hint, it has nothing to do with time. So they convert
Saw that video already.
what?
Saw that video already.
You saw it? So they show time dilation directly from waves. Nothing to do with time. I mean, nothing to do. This it's not special relativity. It's just waves. It's just the way
Oh, that's
waves.
one.
Hmm?
That's what. Yeah, it's one interpretation that you can derive special relativity from. It doesn't mean special relativity is about waves. It's just interpretation.
Yeah.
Yeah. So
Mr.
it's
Slave,
not
I
easy.
provided
Special relativity is about waves.
I provided the only piece of mathematical equation inside of your document. I think you should check it out.
I added the D operator.
Okay.
The D operator.
Okay. Do you
I
like
mean-
my proof that e to the x does not equal prime of e to the x? What do you think about that?
What is D? What is D prime? What is prime? I don't get it. I mean,
What? You don't. Okay.
It's
you
a
don't know how to
deriv-
take a derivative, and
Oh,
you're
it's-
trying to prove
no, I'm just
what?
you're using capital D prime as a derivative notation. I haven't
No,
seen
that's
That's the d operator.
the D operator is the
Yes,
derivative.
as described by big physics. Yeah.
I know. I haven't seen this notation since my freshman year in college.
The d operator. Yeah, it's very old notation.
Why would you use it?
Ask Totoro. He's very fond of the d operator.
Wow. So you're saying that e to the x is e to the x, I guess, times 8? Wait, what's going on? I mean, the
What?
derivative. What is the 8?
Well,
Infinity?
that's a part of the d operator.
What?
Yeah.
yes. Every functional D operator has to have an 8 attached to it.
So it says
Mhm,
8,
mhm.
0, 0, 0, not
Otherwise,
minus.
the D operator simply does not project to the right.
No, exactly.
The D operator does not project to the right?
Yeah,
What?
it's more apparent if you remove that minus there you had there crossed out, gamma, in the equation. Yeah, there. Now the D operator is complete.
What? What is I
Mhm.
don't know what that is. The D. What is this 8?
It's high level maths.
I don't know high level math.
It's. I mean, I understand this is hard mathematics.
Okay. So you're saying e to the x, the
So-
derivative of
Yeah,
e to the x.
sometimes the D operator is relaxed and you
Okay.
know, flaccid.
Anyway, you're saying. Okay.
Yeah.
I don't think. I
Okay.
don't think you're the next Einstein.
That's a pejorative.
Those are tiny fucking legs.
You like
I mean,
that?
sorry,
What do you think about that, Totoro? Does that complete the d operator?
The D
Yeah,
operator.
sort of, but you have to add the function call operator on the other side like this.
yeah.
Okay.
Okay, as much as I'm having a good time, I don't want to waste another day. So I pasted.
This is very productive.
You want
talked about
Bacon
the
to show you his sextant?
Okay. I pasted. Okay, so we already spoke about that.
I can
Anyway,
do that.
okay. So does anybody want to talk about something interesting?
Yeah, Bacon can show you his sextant. Would you like to see his sextant?
No, I don't want. I don't care. Look.
Oh,
What just
You just
happened?
made Bacon very upset.
Bro, it's a big sextant.
yeah.
Yeah, I've seen
It's
it.
his girlfriend.
He showed it
I
to me
would
on
believe
screen.
that.
Wait, is there a girl here?
Oh my
No.
god.
No, that's Bacon's girlfriend right now. She's polishing his sextant.
No, she's a single
Yeah, yeah, yeah.
female. She's a single ding 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 ding.
No.
Wait,
Single female on
Zarmar.
Discord. Ding 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 ding.
Okay, wait, Zarmar. So
Riz up.
are
Mr.
you?
Slave, we've spoken before.
We have
Mr.
about what?
Slave, Sigma, Riz. Oh my god.
What did we speak about?
You told me that because I was vegan, I must feed myself to a crocodile.
Oh yeah, this one.
Doesn't that logically follows?
I don't know.
I see.
All
Okay,
right.
now I remember.
Wait,
Okay.
Mr. Slave, can you
Yeah.
there you go. I want you to say this to Zarmar. Just gonna DM it to you.
Oh god.
Oh Lord.
This is gonna be really bad.
I'm probably not gonna do it. I'm not mean.
It's not mean. It's not gonna be mean.
Anyway, so Zarmar, how long have you been around these people?
I don't know. How long has it been, Sea Lion?
That's good. That
Yeah,
is.
go on, say it. Say it to her. Say it to her.
No, I will never.
What did it DM it to me too, Jekyll?
That's very
Yo,
good.
we got our friend high up level here.
Who?
Yeah, think about high up level.
What do you mean? Anyway,
You
so
wouldn't want to.
so Zarmar, are you a physicist?
No.
So what do you do when these people talk physics?
I listen, and I try not to be confused.
Hmm.
That's almost as good as Jekyll, except for Jekyll just gets confused anyway.
Yeah, true. Not wrong.
So, Zarmar, can I ask you a question?
Yeah, go for it.
All right. So, why do you think an apple falls towards the ground?
There's this thing that people call gravity. No one seems to be able to explain it perfectly. I assume it exists.
Mm-hmm.
Because, it's just convenient that way.
Okay, but I mean, gravity is just the description of the fact that the apple seems to accelerate towards the ground. That's just like a shorthand of the story. But what's causing the apple to accelerate towards the ground?
Ether?
Okay, go on.
It's ether, right? Because it's everywhere, right? And
Always has been.
yeah, right?
It has to be.
It has to be. So it has to be ether,
Well-
and it's everywhere. It makes things stick to the earth because ether is good. It doesn't want things to float away, right? Yeah. So it's
the earth.
ether.
It also makes things stick to your shoe.
Yeah,
Lots
yeah.
of things stick.
This was incredible stuff I heard today.
Did I get it right, Mr. Slave?
I don't know. You need to tell me. Are you convinced? Can you really explain to me why the apple accelerates towards the ground?
No. To be fair, no,
Okay.
I cannot.
Okay.
It has to be ether, though. It has to be
Why?
because it has to be. Tis ether.
Why?
Good one.
I mean,
She's learning so quickly.
you can call it whatever you want. I just need the story. Give me the ontology. Give me the story why the apple accelerates towards the ground. I mean, the apple doesn't have wings to flap, or there's no the apple doesn't reach and grab the earth and pulls itself, or maybe it does. I don't know.
I mean, are you suggesting that we need wings in order to do movement?
I'm just asking, why is the apple accelerating of its own accord towards the ground? Why are you right now feeling this force? Your tushy pressing against the chair. There is a force there. Where is this force coming from?
The chair is pushing back.
Exactly, it's pushing back. That
Yes,
means
yes.
that
Well, you
means.
see, the
Mhm.
crocodile lives underneath the earth, right?
What
It's
do you
so
mean?
it's so the ether wants me to be fed by the crocodile, but the
What?
chair doesn't want me to.
Oh, you're going back to the crocodile. Okay.
Someone brought it up. I thought it was funny.
Because she's
Yeah.
vegan.
Yeah.
Mm-hmm. Anyway, we'll come back to the crocodile if you want. Well, what would you rather talk about? The crocodile or the apple? Or you want some of both?
I want high up level to explain to us how to do navigate. Oh no, he's gone already.
If he's not the center of attention, he leaves pretty quickly. He asked me for help to fix Flat Earth, and I said no.
Why would you say that? I mean, you lost a big opportunity there. I mean, I never had so much fun as trying to help flat earthers fix flat Earth.
Oh wait! He's not done though. He's putting shit into the channel.
Anyway, Zarmar, what would you rather talk about? The veganism, the crocodile, or the apple and the gravity?
Can you find a way to combine the questions?
I can intermingle. I can do a little bit of each so that you don't get bored.
So tell me why the crocodile falls down.
You want me to tell you, or do you want to go through the Socratic method whereby
You
I'll.
know what? Let's do the Socratic method. Okay. You have to ask me a question to lead me somewhere. So ask me a question.
Okay. Okay, so do you think it's possible for the apple to move closer to the earth without a string, without anything attaching, without without a hand, without something pushing the apple towards the earth? Do you think the apple can move towards the earth without any means by which it will propel itself? Can the apple?
Well, I've seen it happen. And I'm not sure if there are a means or not.
What's your intuition?
Intuition? I don't think it is intuition. I think it's more so something I've seen.
Okay, so let's say there is a vacuum, right? There is pretty much a vacuum. Well, certainly between the moon and the earth, there is a vacuum. How is the moon?
I am told this.
Right. So how? Right. There's no strings between the earth and the moon, or the earth and the sun, or the apple and the earth, or you and the earth. There's no string. So why are these things being pulled together? Why are these things attracting each other? And the crocodile and the
Invisible force.
Go on.
I think there's an invisible force that I don't know anything about.
Mm-hmm. Did you know that right now, if you placed a test particle a distance infinite from Earth, it will start immediately accelerating towards the Earth?
I assume this is true.
How is this possible? You place a test particle at an infinite distance from Earth.
Oh, I didn't hear the infinite part.
Yeah.
I'm not sure if that's true or not.
Well, according to, well, we're not sure of anything, but that's pretty much the way it works. I mean, anywhere, let's not go to infinite, but anywhere in space you place a test particle, it immediately starts accelerating towards Earth.
I'm 99.99% sure that this is not how the Socratic method works.
Okay. So Mm-hmm.
Each question you ask, I give you the same answer. I think it's an invisible force. People call it gravity.
Gravity, I would say, is the phenomenon. Well, okay. Here, I'll give you a Socratic question. So I'm gonna put you in a space capsule, or even better, imagine the universe is empty. There's no planets, no stars, no galaxies. It's an empty universe, no Earth, and all there is you inside a space capsule. So far, so good.
Okay.
Okay, now you have an apple in your hand. So far, so good.
Yes, I assume if I drop the apple, it's going to float around.
Yeah. Now, the Socratic method. I would like you to somehow simulate gravity. Simulate somehow the apple falling towards the ground, whatever you define the ground to be. Either, you know, pick a side, pick a spot on the space capsule and define that as the ground. And now you can do whatever you want in order to simulate gravity. Make the apple pretend to or accelerate towards what you call the ground. How would you do that?
Easy. I'll throw the apple at the ground.
Okay, good. But notice that if you throw the apple at the ground, will the apple accelerate? Do you know the definition of acceleration?
Yes, it's a change in velocity.
Very good. So if you throw the apple, will that really simulate gravity?
No, but there is no gravity there anyways because everything is gone.
Right.
But I could put the apple out of its misery by throwing it against the wall really hard.
Yes, but will that simulate gravity?
Or feeding it to the crocodile.
Yes, but will that simulate gravity?
Absolutely. If I feed myself the apple and the space capsule to the alligator, it might develop enough mass in order to form another Big Bang and give reality like another chance.
Incorrect. But anyway, Mordwan, if you go look inside of the Golden Glober chat, Bacon just basically agreed the Earth is flat.
Yeah,
Bacon,
Earth flat.
yeah, Bacon, go unmute your mic, bro. You told me come in here. I'm in here. How do you feel to prove the
Teach us Salnav on flat Earth. How you
first
do it?
admit that Bacon admitted Earth is flat.
I'm trying to get him in here.
Wait,
Yeah, he told me.
me and Zarm are at the middle of a very interesting conversation.
This is more important.
Oh yeah, this is way more important, bro. You just sit aside. Bacon,
Zarmar,
bro.
Zarmar, do you want to go to a different room?
Yo, my friend, what's up?
Bacon, how do you
I
feel?
need to hear more about this. Sorry. Yeah, go ahead.
Bacon, how does it feel to prove flat Earth? I mean,
Fantastic, bro.
First you did a. I mean, you can troll all you want, right? But it's already in Golden Globers. But
Well, the feeling is mutual.
Are you cutting me off? Is that what we're doing? Why are we cutting each other off? But first today you did a 3-star fix on a flat Earth. Thank you for that. And now yeah, you did. Now you're saying that the Earth is flat. So you're a flat earther. I don't know what to tell
Oh, wait
you.
a second. When did I do that?
Stop cutting me off.
You mean the ChatGPT one?
Stop cutting me off. Yeah, so you're a flat earther, officially. And welcome to Flat Earth.
Wait,
So
Thank you.
wait,
hey,
high up level. Can I ask you a question?
Mr. Slave, stop
No, you
cutting me.
can't. You're cutting him off. Stop cutting him off.
Naked, you're a troll, bro. This is why like nobody takes you serious. Viking already beat you in the debate. I did. Like you're not even competition at this point. So yeah. So
Right.
you admitted the Earth is flat. So the Earth is flat. All right.
Wait, can I?
So
Can
how
I?
do we do cell nav on flat
Wait,
Earth?
wait, hold on one second, one second. My turn, my turn. Wait, high up level. Can I ask you a question?
No.
What do you mean? Why not? So
you
does that
you
mean
asked me.
Does that mean
You asked,
Well, he said no, and then you ask why not. He just said no,
yeah,
and then you reply with another question.
yeah. You
Come
asked
on,
me.
bro.
I
Don't you know
gave.
what no means?
Wait,
I actually.
so that means you're not engaging in a debate.
Bro, no means no.
Okay, that's fine. So I'm gonna move to concluding remarks. You just disengaged from a debate. That means you lost a debate.
You never said that it was going to be a debate, and that was too late to say it. So yeah.
Anyway,
Uh,
you disengaged from a debate, so
cut
you
me off?
lose.
Cutting me off? Are you cutting me off? Follow your own rules. You said if somebody cuts you off, you automatically win the debate. So you just cut me off. Now I automatically won a debate, right? Okay, that's your
No,
logic.
that's not my rule. Actually,
Yeah, that is.
in my rules, I allow people to cut each other off all the time.
That's another win for Flat Earth. You just cut me off again. Now
Why?
Bacon,
Why do you think I have anything against flat Earth?
another cut off. That's 3 wins in a row. You see how dumb your logic is, bro? Just take that out your sight.
What's your point?
I
Why is it so important for you to win
Take that.
debates?
Okay, let me fix this.
Oh, Mr.
Done.
Slave just
Go
said
ahead.
why it's so important for you to win.
Oh,
His whole site is about winning a debate if you get cut off.
okay, focus. Let's focus.
Yeah,
Right. So I'm a
yeah,
flat earther now. You
yeah.
said I've done a CellNet fix, right?
I mean, you're a flat
My
earther.
CellNet fix. Oh, please don't cut me off. Please don't cut me off.
Is that in your
My
rules?
CellNet fix. Bro, you're cutting me off. No, cut me off. My CellNet fix that I did on flat Earth, of course. It had 3 different points of intersection, and they were hundreds of miles apart. Right? I don't think I was hundreds of miles apart in 3 different locations. So that's not a very good fix. I want to know how to do the right one, the one that doesn't give me hundreds of miles of error.
That's
Could
not
you
what I
help me
see.
do that? Hmm?
That's not what I seen on your screen, brother.
That's exactly what it was in my screen. One of the circles didn't even intersect the other two.
Literally said verbatim, "Oh, this is actually right."
Yeah, I was saying that one was
Anyway, what a complete waste of time. How people are wasting their time with these silly debates. My God. They're trying to convince each other of nonsense instead of actually doing something productive with their lives. Really, really sad. Anyway, what do we got? What do we got? Let me see what's going on. Let me see. Okay, let's watch this. Cardi B teaches women that low self-esteem. Bodybuilder gets humbled by Navy SEAL. Young Turks upload Cenk rages at Benjamin Netanyahu's UN speech. The Kardashev and Barrow scales of alien civilizations. The Kardashev scale is dumb. It's like let's measure the amount of energy in order to measure progress of a civilization. That doesn't make any sense. Anyway, genetic engineering immoral. Vivek Ramaswamy. Tim Pool's dad. All caps. Very good. Trump want to work at McDonald's. What? Okay. Let's get back to home. Physics, quantum theory, pilot wave. I don't like it. Airbnb host tips. Euler's identity proof for Calculus 2 students. Euler's identity. Okay, I can already see it on the board. Okay. Statistics, couple moment practice problem 2. Statics. Okay. Advanced quantum mechanics. Number 6. Derivation of ladder operator. Trump meets Zelensky. That's good. Let's see.
So it could be more of a co-equal partner. That is still the whole time.
We are really way.
What type of private communications has responded to out and out 1950 style racism, which is
Okay. Exploring triangles of equal area and perimeter. Interesting.
Welcome back to the series on helicopter aerodynamics and control. Today we're looking at a key aspect of helicopter control, the flapping degree of freedom. Helicopter rotor blades generally have 3 degrees of freedom. These are flapping, feathering, and lead lag. Understanding these is essential for understanding how helicopters are controlled. Controlling a helicopter is achieved by tilting the rotor disc in the direction we want the helicopter to fly. This tilt of the disc requires 2 things. First, it requires controlling blade feathering with a device called a swash plate. And it requires the ability for the blades to flap. If you're interested in how the swash plate mechanically controls feathering, I have another video in this playlist dedicated to that subject. Let's start with a review of all rotor blade degrees of freedom. Feathering, which is also called blade pitch change, is controlled by the pilot through the collective and cyclic sticks. Feathering affects the blade's angle of attack, which changes the amount of lift produced. Changes in lift are what control the helicopter. But control also requires the other 2 degrees of freedom. Lead lag is the motion of the blades in the rotor's plane of rotation, and flapping, which allows the blades to move up and down relative to the rotor's plane of rotation. Flapping is essential for aircraft control, and this video will explain why flapping is essential for aircraft control. Another video in this playlist will cover lead lag motion. When a helicopter is sitting on the ground, with the rotors stopped, the blades don't produce any lift, and gravity causes the blades to rest against their droop stops. And by the way, droop is the term we give to negative flapping. If you said the blades are flapping downwards, you wouldn't be wrong, but droop is a more common term. Blades droop down and flap up, but that angle is always called the flapping angle. As the RPM increases and the pilot raises the collective lever, the blades begin producing lift, and this causes all of the blades to flap upwards. They flap upwards until they reach an equilibrium position where they take on the appearance of an inverted cone. The angle you see here is referred to as the coning angle of the rotor system. The coning angle will vary based on gross weight. A higher gross weight results in a higher coning angle. And before getting too deep into this video, there's an important point I'd like to make about the animation you're seeing right now, and that you'll see in the rest of this video. Blade flapping only happens when the rotors are turning. Flapping is an aerodynamic reaction to blade pitch change. Without rotation, there's no change in lift, so there would be no flapping. But for clarity in the animation, I'm allowing the flapping response of the blades, even when the rotors are stopped. Think of this maybe as a stop-motion video where you're able to look in the rotating frame of reference without spinning around the helicopter. In some cases in this video, I'll exaggerate the flapping response so that it's easier to see in the animation. When I zoom in on the rotor hub, you can see the hub arms are biased towards a non-zero coning angle. This is called pre-coning, and the hub is designed this way because the helicopter will hover at a minimum gross weight that results in a minimum coning angle. Designing the hub with a pre-coning angle means the blade spindles spend most of their lives centered in the hub and have more clearance from their mechanical contact stops. The coning angle is formed because of equilibrium, or a balance of forces between lift and centrifugal force. In the animation, the green vector shows the lift on the blades. Collective input changes the lift on the blades, and this creates a moment about the flapping hinge that causes the blades to flap. But because of blades are rotating, centrifugal force, represented by the red vector, creates an opposing moment about the flapping hinge. The centrifugal force only creates this restoring moment when the blades flap out of the plane that's perpendicular to the rotor mast. So lift always wants the blades to flap away from neutral, but when they flap away from neutral, centrifugal force always wants to bring them back to neutral.
1 second. Hey, Spaghetti, how are you?
It's Mr. Slave.
Yeah. Why do you always like come and go so quickly? Like we barely get to speak. So Sean Carroll says that the universe has a wave function, whatever. Do you think that makes sense?
Yeah.
Explain. What predictive power? What can you predict through the wave equation of the universe that you can test?
The state of the universe.
The what?
The state of the universe.
Yeah, how can you test it? Like, what prediction can you make that you can test? Otherwise, it's unscientific.
All of them.
That what? What? You said hold on?
All of them.
What prediction? What do you mean all of them? What name a?
Well, I could probably make predictions about birds.
About birds?
Yeah, I could predict like whether a penguin will catch a fish or be eaten by a seal.
Oh, okay, yeah. Mm-hmm. That's very good. So, right, you agreed before that even for a baseball, it wouldn't make any sense. There's no prediction power. Therefore, it's unscientific to apply.
Well, what's your favorite kind of penguin?
What's my favorite type of penguin?
I don't know. I asked you.
I never tasted a penguin. How can I know?
Where are you from?
I don't discuss that on my channel. It's I'm anonymous. I'm an American.
Nomina? Or
Nominous.
what?
I'm an American.
Oh,
I mean, I'm not I'm not wasn't born an American, but I transitioned into an American. I identify as an American.
uh-huh.
So, can you explain to me what was the big deal with Heisenberg's uncertainty? Like, why do what?
Yeah.
Okay, I'm listening. Ready when you are.
What?
What?
What are you waiting for?
I'm waiting for your explanation of Heisenberg. What's the big deal with Heisenberg? Like, okay, delta x times delta p is greater than or equal to h bar over 2 or something?
Yeah, I can prove that using Fourier transform or something.
What?
Yeah, I can show that the wave function in one basis is the Fourier transform
Right, so I
of the
saw.
wave function in the other basis.
I don't know what you're saying. I'm going to raise the volume to the maximum. Okay, wait, what did
Yeah,
you say?
you can prove this using the fact that the wave function in one basis is the Fourier transform of the wave function in the other basis.
What do you mean? What is a basis?
Like a basis of a vector space.
Yeah, I saw a video where they explained, this is from Fermi Lab, Don Lincoln. So he explained Heisenberg's uncertainty, that it comes out of a Fourier transform from location, well, using de Broglie, location and lambda to momentum. So you mean that's one space and the other space, okay? But how is it? How can you test what is the predictive power of Heisenberg? What did Heisenberg? Right, Heisenberg gave us a theory, right? Heisenberg gave us a theory that has predictive power that was proven to be true, right?
Yeah, you do an experiment and measure things, and you see if the results correspond to it, I guess.
Like, what's the experiment you would conduct to confirm Heisenberg's uncertainty?
You set up a system, and then you make some measurements on it.
Like, what system? Give me an example of a system.
Particles.
Can you explain to me? I want to reproduce the experiment. What would the experiment consist of?
You prepare the system in a certain state, and then you apply a transformation to it, and then you measure it.
But tell me the exact protocol, how to set up the system. Like, okay, I wake up in the morning, I go to the store. What do I buy? What equipment do I buy to conduct this experiment?
Yeah, so you buy a system. Let's call it C. Okay.
But you
and
go
then
to
you take your system and you apply a unitary operator U to it.
No,
And then
I don't know what you're saying. So I go to the store. What equipment do I buy? Give me the list of.
you buy a system and you need to buy a measuring apparatus.
I don't know what that means.
You buy something to measure it.
Like the double slit experiment. Does that count?
I guess so. So you could buy like a positive operator value measurement in this general case, or you could buy just buy some Hermitian operator your choice.
I don't know. I didn't get to Hamiltonians yet. So I go to the store. I buy what the double slit experiment. Is that a good system? Yes or no? I don't understand.
Yeah, I guess so.
Okay. So what's the prediction that you're making? Okay, I know how to conduct the experiment. Let's say I take a laser and I'm gonna send the laser through two
The
slits.
prediction is that when you make the measurement, you will get certain results.
Yes, but that's not from Heisenberg. That's from
Yeah, but you can
you can
you
predict.
could infer, yes, you can infer Heisenberg's uncertainty principle
You can
from the results.
you can predict diffraction based on Heisenberg?
Yeah, I guess so.
How? Why would you predict diffraction? I mean, diffraction comes out of just experience that a laser beam is light, and light is a wave, and waves diffract. How is this from Heisenberg? How did Heisenberg know
Well,
that?
all waves.
What?
Yeah, all waves satisfy some form of an uncertainty principle,
But some uncertainty
not
does.
just quantum wave functions.
Wait. Okay, so Heisenberg predicts diffraction?
Yeah,
How? Where in
and he would
Heisenberg?
have. Well, he probably did.
What do you mean he probably did? No one ever
Probably
did.
did.
Diffraction has to do with wave mechanics. That's even before Maxwell. People knew that. I mean, the younger.
Okay, well then he knew about it, so he predicted it.
What do you mean he knew about it? He predicted it. You cannot predict after you know. You have to predict before you know.
Okay, so he did something.
Well, that doesn't count. What prediction can did Heisenberg would I make based on Heisenberg's uncertainty in the double slit experiments?
You would predict that you would get certain measurement results.
Well, I know that I'll get some measurement results because I'm going to conduct the experiment and I know how to run the double slit experiment. I know I'm going to get a diffraction pattern. I've done it many times before. But where is
Anyway,
Heisenberg?
what other kind of birds do you like besides penguins?
I just like eating birds. I once ate when I was young.
What?
I ate a dove. Doves are delicious.
Oh, really?
Doves are by far more delicious than a chicken. It's like a chicken is disgusting compared. It's not disgusting, but doves are. You cannot imagine how delicious doves are. You cannot until you taste them. You cannot begin to imagine.
Mm-hmm.
It's a delicacy. It's better than duck. Like duck is more delicious than chicken.
Mm-hmm.
But a dove is by far more delicious than anything.
Okay, what animals do you like?
I like all animals as long as they behave. I like
Or
cats.
what animals do you like that you don't eat?
I mean, chickens. I mean, dogs and cats.
Oh, what's your favorite kind?
Of dogs and cats.
Uh-huh.
As long as they're smart and they behave and they don't drool too much and don't shed too much. And as long as they play, as long as they're cuddly, as long as they want to cuddle, like it depends on their personality more than anything. It's like a human. It's mostly about the personality. Everything else we'll figure out. The most important thing is the personality.
Mm-hmm.
Like I don't like animals that don't like to interact. Like some animals don't interact with me. So then I don't care for them. Like, I want the animal to interact with me and to enjoy my presence and to miss me when I'm gone and to wait for me, and when I enter the room and come into, their line of sight, they wiggle their tail or they're meowing, or like, I see YouTube videos and like all the animals like are so they're so nice. They miss their owners. So that's the most important thing, is that an animal, but not just an animal, the human animal too. I mean, like, I like the fact that you keep coming back. So that's what I like about you. It's mostly about the fact that you show up. 99% of what I like about you is that you show up. 99% of what I like about dogs and cats is that they show up. It's mostly about showing up. Like, I once had a cat that couldn't care less for me, that I could never get its attention. It was like it was a waste of space. It was always hiding away from me. It never interacted with me. What's the point of that? The same goes for a girl. Like, if you have a girl and she doesn't enjoy interacting with you, then what's the point of having the girl? Like, the whole... Well, that's my point. So can you explain to me what prediction I can make based on Heisenberg's uncertainty?
Yes.
Then can you tell me, like, in the double slit experiment, what is the predictive power? Everybody keeps talking about Heisenberg. What's the big deal with Heisenberg? Why did Einstein hate Heisenberg so much? Why did everyone hate Heisenberg so much? Like, I don't understand. What's the predictive power of Heisenberg? Ready when you are. What? You don't know? Do you think that a hydrogen atom has a wave equation associated with it? What's the predictive power of the wave equation of a hydrogen atom? What can you predict?
I'm boring.
You're boring.
I'm boring. Boring with this.
You're boring with
I don't want to
this.
talk about this. I'm boring with it.
Fine, you can talk about anything you want. What do you want to talk about? Do you want to talk about my ether theory?
No. I'm gonna go eat breakfast.
Breakfast. So you're in Australia?
Okay, bye.
Bye. And he's gone. You're not gone. Wait, you're staying in the room? Okay, you can stay. Anyway, so let's continue. We were watching this.
The net effect is the blades settle into an equilibrium position where the moment due to lift is balanced with the moment due to centrifugal force. This balance of moments results in the coning angle. Another important concept and terminology is that the rotor tips all pass through a common plane. This is called the tip path plane, and the flapping degree of freedom is the mechanism that allows the tip path plane to move. Motion of the tip path plane does two things. It tilts the overall thrust vector of the helicopter in the direction we want it to go, and it applies a control moment to the rotor mast. This is also in the same direction we want the helicopter to go. In the case of the control moment, the further the flapping hinges are from the center of rotation, the stronger the control moment becomes. This distance is called flapping hinge offset. Here I've exaggerated the amount of flapping to help visualize how centrifugal force pulling outwards on each of the blades contributes to a control moment on the mast due to hinge offset. These two effects, tilting of the thrust vector and a control moment applied to the rotor mast, are how the pilot controls the helicopter, and both of these effects rely on rotor flapping. A summary of this control concept is, blade feathering changes the lift of the individual blades. This change in lift causes blade flapping. Flapping has two effects that control the helicopter. Flapping tilts the tip path plane and the thrust vector, and flapping creates a control moment on the rotor mast due to flapping hinge offset. These control concepts that allow aircraft control in a hover also apply to forward flight, but as the aircraft picks up speed, a few other considerations come into play. Helicopter blades are rotary wings, and they create lift based on the amount of air coming into the wings and the angle at which the air approaches the wing. Air coming into these wings is mostly generated by the rotation of the blades. Each blade element sees a component of velocity equal to the rotation speed of the blade multiplied by its radial position from the center of rotation. But it's not only the blade rotation that contributes to blade element velocity. We also have to add the vector component of the helicopter's forward flight speed. And this is where we start to see a difference between the velocity seen by the advancing and retreating blades. Forward flight speed adds to the velocity of the advancing blade, but it subtracts from the velocity.
I have no idea what he's saying. This is like, I don't understand anything. This is a waste. Incredible. David Wood, an apostate prophet. Okay, let's get back to the most important thing is this. Nothing else is as important. Let me check today's. Wait, who's Shatanu 5 bro? Wait. How and why did I subscribe to you? Who are you? Did we meet somewhere? That's so funny. Let me get that. What's going on here? Who is this? Come back. We're looking at your paper. Okay. All right. Yes.
Except for the Epstein thing. That's the only thing that was said.
Talking wave has reached the talk detector. Okay.
Yeah, so it's tick-tocking. It's
Oh my god, he's back.
Yes, it's a clock.
Yep.
It's based on the dialect video. I just took the dialect video. All they did is they proved time dilation. I went one step backwards and I proved the second postulate, which is even better.
The time contraction?
Time dilation. What do you mean contraction?
How far is your time dilated?
Oh my god. Okay, you said you wanted me to come back, not to waste my time. Come on, stop it.
Didn't say that. I said we're talking about your paper.
Yeah, I don't. Yeah, but we need to be more productive. I honestly, I'm an old man. I don't want to like.
If I may, I'll just read the introduction.
You don't want to talk about your paper.
In order to derive Epstein's second postulate, we will introduce the following thought experiment. This thought experiment will, sorry, I don't know why I said that weirdly. It's just because the text is so large that this thought experiment will consist of a bathtub filled with water. In this bathtub, we will place a rubber ducky. We will add some technological advancements to this rubber ducky. Using these technological advancements, the rubber ducky will measure the velocity of the surface of the water waves. We will demonstrate that the velocity as measured by the rubber ducky will be constant regardless of the rubber ducky relative to the water. Once we demonstrate this conclusion relative to the velocity of the water surface waves, it should become obvious to the reader that a similar process occurs when we, as humans in real life, measure the speed of electromagnetic waves.
How's that obvious?
Just is. Well, the paper says it is. Right? So, and we all know.
Well, you forgot to add at the end, if P then Q, Q then P.
I mean, it should be obvious. I don't want to use the word ether because of big physics. I'm afraid big physics will come after me, so I have to skip.
Pretty sure they won't.
I don't want to take a chance. Big physics, Sean Carroll and Neil deGrasse.
Big physics?
Yeah.
Yeah.
Who's big physics?
It's in the top of the paper, so.
Go gangsters.
It's as
Did you post this paper here? I haven't.
You haven't read his paper?
Oh,
way behind on physics.
I'm sorry.
This is
NASA, go in the text chat and look at my last post there. I have the link in it to it. Definitely worth a read.
What time was it, please?
It's only a few minutes back. It's only like 3 or 4 posts back in general chat.
Why don't you share your screen like before so I can share it?
Of course, I'll share.
You guys want to know how to get kicked out of Earth Awakenings?
Go on.
Oh my God! Is
tell
this really? Excuse me. I'm sorry. Is this really in Comic Sans?
Yes.
Oh my God!
As per
Those
our
were-
advice.
We improved it. We made editorial suggestions to make sure the paper is more publishable.
I'm sorry, Brenda. I just couldn't believe it was. I'm sorry.
No, that's fair enough. I can wait.
No, go ahead. I'm
Just have
sorry.
I just have a joke. I just have a joke. That's all.
No, I just couldn't believe it. I was reading this paper in Comic Sans, and yeah.
That's the only thing you're disturbed by the paper? Is this
So far,
Opens
yeah.
a paper with Epstein and George Floyd on the front cover, and he's like, "What? The font is Comic Sans."
I haven't even gotten there yet. I saw the I forget the guy, the comic guy. That's a Family Guy, right?
yeah. Inspired by Adolf.
Inspired by Adolf Hitler. That's good too.
We're just following the custom of putting all your mentors' pictures on the front page.
I'm really sorry, Brenda. This is amazing.
No, it's all cool.
He's been working on this paper since
Modus
September 11th,
modus
2001.
hyperbolics too. That's a really great equation. I like that.
Gregory supplies all the syllogisms everywhere.
He has monopoly on syllogisms.
Where is this? Where is this paper?
Just watch my stream.
It's posted at 15 past the hour.
This is gonna become the main attraction of this server.
Yeah, honestly, it's a gift that keeps on giving.
Yeah.
Troll the troll.
This is giving me so much humor. I love everyone here. Wonderful people.
We're assuming square rubber duckies.
Yeah.
Cool.
Yes, obviously you don't want to overcomplicate it with needless detail.
What was the method for getting kicked out of Earth Awakenings?
I want to.
It's simple. You tell Geo that his 5-sun model is not from somebody that's interested in the truth.
Oh, I got banned for a week, silenced for a whole week for telling them that the universe is under no obligation to make sense of them.
What do you mean the universe is under no obligation to make sense?
Correct. The universe is under no obligation to make sense to you. If you don't understand something, tough shit.
Then why? That's like then you're pulling the rug under the foundations of science. You realize that?
No, not really. There are people who are a lot smarter than you that may understand some stuff. Just because you don't understand it doesn't mean it's false.
Yes, it does. That is exactly the definition of false.
That's incorrect.
So what's your definition of false?
But it's definitely not stuff I don't understand, because a lot of stuff I don't understand. That
What don't you understand?
Well, I don't understand how people can be flat earthers, for one.
Oh. Did you try to understand?
Yeah, in years I could say Earth flat.
What?
Earth flat.
What do you mean Earth flat?
Earth flat. That's the main. That's the main argument for flat Earth.
Mm-hmm. So you don't understand why people are flat earthers?
Well, I do understand why people are flat earthers. They're dumb shits.
What NASA? Come on. I mean, you're.
Oh, sorry. They're not extremely educated in the ways of science. There's that better.
So according to that theory, once you educate them, the flat earthness should go away.
Well, yes and no, because you can't. When you have a flat earther and you feed them a bunch of knowledge, you end up with the flat earther who ignores a bunch of knowledge. So your theory has been disproven. So what's your next theory? No, it hasn't been disproven.
So why you said you don't understand how people can be flat earthers?
That's correct.
And then you suggested that they lack knowledge.
Correct.
And
But
then,
the problem is that they don't want knowledge.
but okay, then now you're okay, but you
No,
said
I'm not contradicting myself. They lack knowledge, but they don't want knowledge. These two things can occur at the same time. Because there are a lot of people out there that would rather be dumb than learn, because they have this group around this dumbness. I just spent 20 minutes on TikTok, not TikTok, on X or Twitter, listening to cult leaders basically sing Kumbaya around the campfire.
so now do you understand why they're flat earthers?
No, not really.
Wait, before it was no, now it's not really. So are you beginning to understand why they are flat earthers?
Yeah, because they're dumb fucks. I mean, excuse me, they're uneducated in the ways of science and don't understand how science works.
So according to that theory, once you explain to them, they should stop being flat earthers.
Operative word should.
Hmm?
Operative word should.
Should based on your theory. If your theory is correct, then they
Oh
should.
my god, bro. So I have
You
a
ever
question.
hear? Yeah.
What's your educational background?
I have a 2 masters, one in chemistry and one in business administration.
That's based. Did you work at NASA? Is that why you're on NASA show?
No, NASA show was a joke because they were always calling everyone NASA show, so I named myself that just because it was. And generally, it goes over the head about 99% of flat earthers.
Anyway, to claim that the universe is under no obligation to make sense to you, then you might as well, do a rain dance when you want it to rain. Then you're saying the universe is under no obligation to make sense. So
Correct.
why science? Why would you try and make sense of the universe if
Well,
it's
because you can make sense of it, but the universe is not obligated to tell you. And it's going to be a struggle. You have to work for it.
I'm not saying it's not what you said. Now you're changing your statement.
No, that's exactly what I said. The universe has no obligation to make sense to you. You just can't sit back, flunk chemistry, flunk fifth grade science,
But you agree,
and say, "Hey, it should make," and then come up and say, "Oh, relativity doesn't make sense to me." Well, no fucking shit.
Okay, so I vehemently disagree with you and everyone like you.
Go right ahead. I'm in pretty good company.
So of course,
To be fair, even if you aced all those classes, you still won't understand it.
What don't you
No,
understand?
it would help, definitely.
What don't you understand?
Oh, what she's saying is that even if you ace fifth grade science, you probably won't understand relativity, and that's probably a good thing. But if you flunk fifth grade science, you definitely won't understand relativity.
Well, if you read my paper, you'll
I
definitely
read your paper.
So
I read your paper.
So
The first 2 pages are based.
you look at the diagrams and time dilation jumps right at you. So I don't care how dumb you are. That's why I created the rubber ducky. The point is that even a baby will see time dilation with the rubber
Excuse
ducky.
me, the rubber ducky this is serious?
It's what?
You're serious about the rubber ducky?
Yeah.
Well, I thought this was a parody.
No.
He's a troll, dude. He's a troll. Jesus.
Okay. So does anybody want to discuss my paper?
You have comments to go through. Go through the comments.
Mr. Slave, I would greatly appreciate it if you perhaps mathematically derive some of this stuff instead of the diagrams. That's my suggestion.
What What do you want me to mathematically derive?
Time dilation with the ether.
No, this is just proof of the second postulate. Einstein derived time dilation. I don't need to repeat Einstein. I don't disagree with Einstein. I'm just proving his second postulate.
I think you mean second prostate, but
Yeah, exactly. Prolapse.
yeah, or that.
Mm-hmm.
To improve on the paper, you've gotta introduce some new stuff. You can't just say, "Well, my big physics agrees with me." At the very least,
Mm-hmm.
you should include the math and tie it into your ether math.
I don't want to. This paper is supposed to introduce ether by not. Look, I'm serious. I don't. There was a previous version. You could look at the version history that had the word ether in it. I don't want the word ether in it. I don't want big physics to come after me.
Wait. Do you think big physics would come after you?
No, but once I'm kidding. But once they'll see the word ether, they're going to reject it. They're not. No one likes ether. The beauty of this.
So
I like ether.
yeah, we're ether fan.
No, you're not. None of you is.
Hey, Gamma, check your DMs.
Oh Jesus.
I'm not logged into Google, so it's not letting me insert.
Yeah, I will. This is good. I remember this. Okay. I actually.
Jesus
Christ. Never out of the stars of David.
Jesus.
Where does it mention time dilation in this control?
Just search for it.
Wait, did I mention time dilation?
Yes, yes, you did.
Oh, okay.
Unsupported format. Oh no.
Well, you cannot mention one and not the other. They come. It's a package deal.
It's a JPEG.
Yeah. What do you mean unsupported? Okay, here we go.
That's a good point. I shouldn't have the words time dilation in this paper.
But then you cannot have length contraction.
I have length contraction too?
I don't know. Do you?
I don't know. Do I?
You have a rubber ducky. That's for sure.
Anyway, the point of this paper is, look, it's to ridicule special relativity without ridiculing special relativity.
The point of this paper is to troll people in this server who cannot detect the troll if their life depended on it.
Do you think they'll be able to detect the troll now, or is it too?
I'm not sure. NASA Shell wasn't able to, so I think there might be one more person.
Look, I don't know why. Do you think Dialect's video about time dilation, about the sound clock, do you think that's a troll?
I think you should team up with Gregory and record a video with a proper syllogism in it, and then we can talk.
I don't even know what you just said.
DM Gregory, say, hey Gregory, would you record a YouTube video with me with a syllogism?
I don't know who Gregory.
He's gonna be like, "Oh yeah, absolutely. That's what I do all day, every day."
I don't know who Gregory is.
Gregory, he's one of your mentors in a paper. Just go
You're
to page 2.
citing him in your paper, dude.
I don't know who that is.
He's the grand supplier of logic.
I don't know.
Gregory doesn't get out of bed without forming it as a logical argument. He doesn't get on the can.
Second page of your own document cites Gregory.
Gamma, show him.
Yeah. Here is Gregory, right here.
Is this really Gregory? So is every...
Yes, the second.
Did you notice that all flat earthers are of a certain melanin tone?
Whoa.
Is this true?
Not true.
No, it's not true.
Oh, okay.
There are
low
groups
IQ certainly doesn't help, but like,
are they over?
Hold on, Omnivore will clarify. Go ahead, Omnivore.
There are groups of black flat earthers, for example, on Clubhouse,
That's pretty. There's groups that are specifically, black guys, black
but
guys.
They
But-
are black Israelites.
Yeah, kind of. I don't know if they. I'm not sure if they are explicitly, but yes, they're definitely in that vein.
Jacobites.
What did the Jews have to do with this?
They co-sponsor the paper. That's where all the money comes from.
Oh, okay. Never mind. Gotcha.
Yep.
Wait, would you say big
So-
physics is like there's a it's related?
Absolutely. Yep.
Oh, that explains everything.
It's
know.
bankrolled by the Jews.
That's why I knew exactly what you were saying before you even told me.
Incredible.
Mods.
That's enough Jew bashing.
Don't worry, I'll get Jekyll back in here and we'll start it up again.
Look, the purpose of the paper is, I like if I'm able to prove Einstein's second postulate, that means it's not a postulate. But the proof depends on assuming a fluid. So I'm basically saying, look, if you're assuming a fluid, you get the second postulate. So then the next logical step is to assume a fluid, aka the ether. So the reader is forced into submission, into assuming the ether, without me having
Dude
to
is so
say
high.
what.
Yeah. To help the paper, when you want your paper to be taken more seriously, you probably want more than one citation. So I added one more for you. Expand your bibliography a little bit.
Wait, could you show it?
Yeah, I'll show them.
I have a feeling like this might be another troll, but I feel like Totoro is always the kindest of heart. So, yeah, this is, I remember reading this. Yeah, that's a good citation. Yeah.
Wait,
classic.
Did anyone here actually read the book?
Yeah,
I've read some of it.
I've read it all.
You read it all?
Yes.
Did you understand it all?
I understood all the words.
Did you read in German or in English?
In English.
Wait, so you understood all the stuff that he said about this land and this piece of land and that piece of land? It's like it's very
Of
technical.
course.
Really?
I'm from Europe. I know what he's talking about.
Wow, that's such an advantage. I had no idea what he's talking about. Like it was so boring. Jesus. But okay.
He
wow.
just says two things in there.
Mm-hmm. Go ahead.
He says ether cosmology.
No. He says, number one, I'm going to get back at the Frenchies. Okay. I'm going to show them who's boss.
Wow.
And then I'm going to conquer the East and enslave all the subhumans.
Wow.
Well, at least
That's
he's
it. That's all there is to it.
Well, at least he's clear in the message.
Would you agree that in Mein Kampf is not actually anti-Semitic?
No.
It's so far out there that it's hard to categorize it what it is.
But there's no anti-Semitism in Mein Kampf.
Really?
Because
really.
he uses the word Jew in such a kind of overloaded way, then anyone can be a Jew.
No, but I would say the opposite. I would say Mein Kampf, he's actually anti the anti-Semites. He says, yeah. If you read Mein Kampf.
All right. Okay, you can stop trolling now.
Sounding like
I have read it, and it is anyone can qualify. The message in Mein Kampf is, if you disagree with me, you're a Jew.
No, that's not the message.
That is the message.
No. Look, when
You said you didn't understand it, and now you're trying to say that you understand it more than Peter.
You also imply you didn't read it. Or read it all.
No, I listened. There's an audio version. I don't know if it's still available. There,
Right.
there was
You
an
played
audio.
You played at 200% speed and just skimmed it.
200% is just 2x. That's like my normal. That's normal for me.
Really?
I always
Right now,
listen
you sound like you're running at 0.5x.
when I talk, but when I listen, I'm always. You can go to my YouTube channel. Everything is always played at 2x. I never play. I hardly
Should be.
ever play anything at under 2x.
Sci-fi IQ individual right there.
Yeah, that's the key. That's the key to comprehension. Listen to it for fast.
I mean, you just get used to it.
You got to get it into your head before you can, think too much.
Anyway, so he literally says that when
if you're listening to Get Beget, you have a point.
Anyway, so he
No.
says, listen, he says that when he first came to Berlin,
Gravity.
and he was handed an anti-Jewish pamphlet, he laughed at it. He laughed at the people that were giving out the anti-Jewish pamphlets. He laughed at being anti-Jewish. It made no sense to him. He couldn't relate to it.
That is so not true.
What's not true?
I guess all those Jews that died in those
Oh my
camps were
God.
like
Anti-Semitism was one of the main kind of thoughts at that time, especially in Vienna, where he was. And everyone for today's standards was anti-Semitic. Hitler took it to a whole new level.
Right, but
he defined it as a mindset. He defined it as a political position. And there were three types of people: subhumans, Jews, and people who agree with Hitler.
Look, but he says when he first came either to Berlin or to Vienna, I don't remember, and he was handed a pamphlet about being anti-Semitic.
Okay, good. Enough.
I'm
You're
starting
boring.
to go.
Get
I'm
creative.
starting to go towards the troll part of.
Get creative now.
Wait, you want me to give you the quote? I can pull up the quote. I'm
No,
quoting.
we want you to be funny or to shut up.
All
Neo,
right.
do you have something back for us? What are you cooking up?
All right. Let's get back to work. It's amazing how these people are funny, and then suddenly they are not funny and they hate you, and the next thing is they ban you. Everything is so instant today on in the virtual environment, in the cyber universe. Everything is so fast. They're so funny and they love you, and everything is so hunky dory. And the next second, they can literally ban you, no problem. Anyway, let's get back to work. So we were at the second video.
Now we're going to substitute that v squared in our second equation. And that will produce that m over r times v squared, which is this term, n squared h squared over 4 pi squared.
So he's bringing this up. Why is he bringing this up? I mean, he's developing it right now. Oh, this is number 2. Okay, number 2 is the acceleration is equal to Coulomb's force. Okay, but here is number 3, v squared. This is the conclusion of the previous video. All right, so at the beginning of this video, what is he going to do? Let's see.
Now we're going to substitute that v squared in our second equation. And that will produce that m over r times v squared.
So this is the definition of v squared. We're going to plug this in to this v squared. So we're going to have m over r times this thing is equal to Coulomb. All right.
Which is this term, n squared h squared over 4 pi squared m squared r squared is equal to z v squared divided by 4 pi epsilon naught r squared.
Right.
And from that, we can work out what r is. R equals m n.
Okay, so we need r. How do we get r? I don't want his hand. Okay. So r, how would you get r? I mean, theoretically, you can invert this, and then it's such a mess. Like, I would first of all get rid of this r. There's an r squared here and an r squared here, so you can get rid of these two r's, and then invert everything. Invert this side over, and invert the m. Kind of difficult to read what he's saying here, but he's saying that r. I guess what is he doing? Is he I guess he's bringing the r over to here, and the z is going to bring over to here, and this thing is going to bring over to there. I guess, I don't know.
Over 4 pi squared m squared times.
This is m. Why is there an m on top? How is there an m on top? I don't know. Oh, because he inverted this, and then the m goes to here. This entire thing goes on top here, so m n squared h squared is over here. And then you multiply by the bottom, 4 pi epsilon naught, but r squared drops out.
4 pi over 4 pi epsilon over z.
Over ze squared. And then you also have, well, 4 pi drops out. Okay, this I'm already lost. I mean, he's skipping a step here. It's too much.
E squared.
I can't.
Times 4 pi over 4 pi epsilon over z e squared.
Let's see. So this thing goes down to here, and this thing goes up to here. The r squared drops out, and then this thing goes to here, and this thing without the r squared should go 4 pi squared m squared, right? But 4 pi should go away too. That's the next thing, I guess.
Which is epsilon naught h squared over pi m e squared times n.
So 4 pi, but there is a pi left because this is 4 pi squared. So epsilon naught h squared over pi
m squared over z.
But
this term
m e, where's z? Oh, z is outside. M e squared n squared. Wait, there's an m here. Okay, so this becomes an m. That's fine.
Is just full of constants and can be reduced to a single constant, which we call a naught times n.
So all this is just constants, and this is n squared over z. These are all constants.
Squared over z. And a naught. As the
n squared over z.
Bohr radius. Now, from the second equation.
Why is that the Bohr's radius? But fine.
We can multiply both sides.
That's because r equals to a constant times n squared over z. So since it's n, then obviously this is r0. Why is he calling it a0? Anyway, the next step is equation 2 again.
By r over 2. And we get this, the half mv squared. We can multiply both sides known as the Bohr radius. Now, from the second equation, we can multiply both sides by r over 2. And we get this.
We can multiply both sides by r over 2.
The half mv squared.
Both of these sides? Both of these sides? mv squared over r times r over 2. So you get 1 half mv squared, okay. And the other side, you get r. What's going on? Okay. Okay, they can do whatever they want, you know. I'm not interested in interacting with that server. It's a waste of time server, unfortunately. Like, even smart people in large groups stop behaving like smart people. They're just little children. Just little children. With all, everything, with all the negative aspects of little children, including bullying and harassment. Okay, so 1/v squared. So, okay, one R drops out, and there's a 2, so this becomes an 8.
Equals ZE squared divided by 8 pi epsilon naught R.
Yes.
And we can substitute that value for half mv squared into the first equation, where energy is half mv squared, which we now know is...
The first equation is E, I guess, equals 1/mv squared. So 1/2mv squared is this, which is this. Okay. So we have this minus that. Okay.
ZE squared divided by 8 pi epsilon naught R.
So ZE squared 8 pi epsilon naught R minus this thing, ZE squared over 4 pi epsilon naught R.
Minus the Coulomb term, which is ZE squared over 4 pi epsilon naught R. And that's a fairly easy piece of maths. That's just minus ZE squared.
So this is 8 and this is 4. Everything else seems to be the same. So this is basically 1/2 minus 1. So it's negative 1/2. So it's just negative over 8.
Over 8 pi epsilon naught R.
That's the total energy.
Now we are going to substitute into this equation the value that we got for R. So we will say that E...
I think he just turned on the lights. Okay, so E equals this. What is he going to do next?
Equals minus ZE squared over 8 pi epsilon naught. And now
That's
we need
this.
another R, but instead of R, we're going to write pi mv squared over epsilon naught.
This is A0 n squared over Z is equal to this, but what are we trying to do now? So E equals this. This is E. He hasn't touched it. So what is he trying to do?
Naught h squared times Z over n squared, which comes to a rather stark...
So I think he's just taking this thing. So R equals that. But that's E.
Right, pi mv squared over epsilon naught h squared.
No. Where is this coming from? Pi. I don't know, something. Is it an M? This is epsilon naught h squared. I think is this it? This is the inverse? I don't know. Is he saying what he's doing?
We will say that E equals minus ZE squared over 8 pi epsilon naught. And now we need another R, but instead of R, we're going to write...
Okay, we need another R, but instead of R, he's going to write, I guess, this thing, A naught n squared over Z.
Pi mv squared over epsilon naught h squared times Z over n squared.
So the pi me squared, where is that? Oh, it's 1 over R. Okay. So R is equal to this, and he needs 1 over R. So he's inverting. Z's on top, n squared is at the bottom. Pi, I guess, me squared is at the top, and epsilon h squared is at the bottom. Okay, good. So that's the R from the E. That's this R. So everything is fine so far.
Which comes to a rather startling minus me to the fourth.
So what does this end up as? So the pi's drop out. Epsilon is squared. Z squared. E squared is e to the fourth. Jesus, what's going on? Is this right?
Divided by 8 epsilon naught squared h squared times Z squared over n squared. But if you look,
this is the solution to the Schrodinger equation for any atom with 1 electron and Z protons. Let's try this again.
Divided by 8 epsilon naught squared h squared times Z squared over n squared.
Okay. So it becomes, so z squared over n squared, I saw, z is twice, and all this thing, pi over pi, the pi disappears, e's to the fourth, we notice that, epsilon is squared, we notice that, h is squared, we notice that, and there's an 8, fine, everything is fine. So this is the energy. The solution is the energy. Isn't the solution the equation, the wave equation? Shouldn't that be like a sign?
But if you look, this term is just a constant, and it's often called the Rydberg constant, R. And if you calculate it,
Oh, this is the Rydberg constant or the Rydberg constant. But this is just the total energy of the system. I wanted the Schrodinger equation.
you will find it comes to 13.6 electron volts. So what does this tell us? It tells us that the energy of an electron in a hydrogen atom can have only specific values of energy, which equals minus 13.
Oh, so that's already the first solution, the first conclusion or prediction of Schrodinger's equation is the energy of the electron. So it's 13.6 electron volts. That's the energy of the system. Well, that's not electron volts? Volts is energy? No. Something is wrong here. Volts is energy? Maybe electron volts? No, volts is not energy. Something is wrong with the units, with the dimensionality.
An electron in a hydrogen atom can have only specific values of energy, which equals minus 13.6 times z squared, which of course is 1 for hydrogen, divided by n squared, and n is an integer. Today we're going to look at the implications of the solution of the Schrodinger equation for the hydrogen atom. In my earlier video, I showed how we moved from the Schrodinger equation to its solution for the hydrogen atom. The full Schrodinger equation that has to be used is minus h bar squared over 2m times d2 psi by dx squared plus d2 psi by dy squared plus d2 psi by dz squared plus the Coulomb term ze squared over 4 pi epsilon naught r psi equals e psi.
Right, so I mentioned in that lecture that he missed this term and the parentheses. It's fine now. Yes, so this is the timeless Schrodinger equation.
I pointed out that that was a very difficult term to solve, but that we would do a cheat solution.
Yeah, the problem was that this is in radial coordinates and this is in Cartesian, yeah.
And we ended up with a formula that said that E, energy, equals minus me to the fourth over 8 epsilon naught squared h squared times z squared over n squared.
So we said in the previous lecture, at the end of the previous lecture, that this is the energy. Okay.
And I pointed out that this term is just made up of constants and can be reduced to a single constant, the Rydberg constant. And so this becomes minus r times z squared over n squared. The Rydberg constant has a value of 13.6 electron volts. This, I explained, meant that the energy of the electron in a hydrogen atom is constrained by this formula. The electron can only have the energy given by the formula. Since in a hydrogen atom Z equals 1, because there is only one proton, the energy levels are governed by the integer values. So when n equals 1, the energy of the electron is minus 13.6 electron volts. When n is 2, the energy of the electron is 3.4 electron volts. Let's not worry about calculating how many electron volts the electron has. Let's just look at the proportions. We go back again to n equals 1. That's 13.6 electron volts. When n is 2, the electron energy is only a quarter of that. When n is 3, the electron energy is only a ninth of that, because it's 1 over n squared. When n is 4, it's only 1/16 of that. When n is infinity, the energy is 0. That means that the electron can escape the hydrogen atom. It is no longer bound. All these negative terms mean that the electron is bound to the hydrogen atom, and you have to give the electron energy if you want to get it out. That means to get an electron to go from that energy to that energy, you have to give it energy. Whereas if an electron falls from that energy to that energy, it gives up energy. So what is quantum mechanics telling us? And more specifically, what is the solution to the Schrodinger equation telling us? It is saying that
it's a well. It's an energetic well. So the electron, you need to give it energy in order to make it fly away. And as it goes into an atom, it wants to fall all the way to here. It wants to lose energy and drop to here, to the minimal state. Now this is just, I guess we're taking the Rydberg. This is the Rydberg. This is, the next value is times 4. This is Rydberg times 4? I don't get it. How do you get this number? What are we looking for? What are we looking at? Oh, it's divided by n squared. Okay. So it's divided by n squared. So this is Rydberg over 4, because 2 is 4. So Rydberg over 4, Rydberg over infinity is 0. This is incredible. Absolutely incredible.
At the energy levels of an electron or hydrogen atom, and you have to give the electron energy if n equals 1, the energy is 0. That means that the electron can escape the hydrogen atom. It is no longer bound. All these negative terms mean that the electron is bound to.
Look, this teacher is just the best in the world. Like everyone else I listen to, I have a very hard time understanding. This guy is so crisp. Every word he says is knowledge. Absolutely amazing.
The hydrogen atom, and you have to give the electron energy if you want to get it out. That means to get an electron to go from that energy to that energy, you have to give it energy. Whereas if an electron falls from that energy to that energy, it gives up energy. So what is quantum mechanics telling us? And more specifically, what is the solution to the Schrodinger equation telling us? It is saying that the energy levels of an electron in a hydrogen atom are constrained to be only these. An electron cannot, for example, have an energy here. That is not allowed. But how does an electron change energy levels? Well, the answer is it either has to receive energy if it's going to move up the energy level, or it has to give off energy if it moves down. Where does this energy come from? It comes from photons. What happens is an incoming photon hits the electron and transfers its energy in total to the electron, and the electron.
No. No. There's no. I don't think so. I don't think energy is transferred to the electron. I don't think so. This is like a person at ground level. Or you could say the person is at ground level. Then he goes down an elevator to here, goes down an elevator to here, goes down an elevator, goes down to here. Nothing changed. The person doesn't have energy. The person didn't have energy. The person here, the system of the person here has energy, and the system gives up energy for the person to go down to here. The person is not aware of the energy that it doesn't hold on to the energy. The system of the person, let's say the person is in an elevator. As the elevator goes down, it has to give away the energy in order to go down. It's the system giving up the energy. It's not the electron. The electron doesn't have any energy in it. The electron doesn't become more energetic. You're pulling up the right. The electron is always the electron. You're pulling up the electron and freeing the electron. It's the same electron. It never changed. Nothing ever changed. Didn't change. Nothing changes about the electron. I'm trying to think. The wavelength of the electron? No. Just that as the electron goes up, the path is longer. If the path is longer, it covers you. We need more lambdas. There's just more lambdas that fit, but it's the same electron. Its frequency doesn't change. I don't know. Maybe I'm wrong. My intuition is that it shouldn't change. Nothing about the electron should change. Its velocity, well, its velocity, right? Does Jupiter travel faster than Earth? Well, it has to. Right? The faster Earth travels, the more it's going to spiral away from the sun and relocate to a higher orbit. So the same goes, this is the same inverse square law. So the electron needs to be accelerated to go to here. But its wavelength has its wavelength changed by going from this energy level to this energy level? I don't know. Well, its velocity has changed. That means frequency times lambda must have changed. Either the frequency went up or lambda went up, or both, in order for the velocity to have gone up. What else could have changed? I don't know. Let's see if he's going to solve it.
Moves up to the next energy level. But it will only do that if the photon has precisely the amount of energy that is represented by the difference between these two energy levels. If the photon does not have that precise energy difference, the electron cannot move because
I wouldn't say that. I mean, if the photon has more, then the electron could go up to here. Yeah, the problem is that the photon, you can't split the photon in two. Why not? Why can't you? You can bring the electron to this level, to halfway through, and then the electron is going to drop to here, and the leftover, you'll get a photon that is exactly the leftover. I don't know. Can this happen? I don't know.
it cannot move here or here. It has to go precisely to the next level. If the electron drops down from this level to this level, then it will emit a photon. And that photon will have a very precise energy, because the energy will be precisely the difference between the higher energy level and the lower one. But we know that that energy is given by h, that's constant, times f, the frequency. And therefore the frequency of that photon will be very precise indeed. At this point, you may be wondering how we can possibly know any of this, and whether any of it is susceptible to experiment.
Oh, he's talking about...
Because the energy will be precisely the difference between, because it cannot move here or here. It has to go precisely to the next level. If the electron drops down from this level to this level, then it will emit a photon. And that photon will have a very precise energy, because the energy will be precisely the difference between the higher energy level and the lower one. But we know that that energy is given by h, that's constant, times f, the frequency. And therefore the frequency of that photon will be very precise indeed. At this point, you may be wondering how we can possibly know any of this, and whether any of it is susceptible to experiment. And the answer is, it is susceptible to one of the easiest experiments of all time. Indeed, the experiment had already been done when this work was done by Schrödinger, so it was very easy to demonstrate that this solution was right.
So these guys keep commenting on the paper, but when I join them, they do nothing but laugh, so I don't know what to do with them. I mean, I don't want to waste any more time. So what is the experiment that verifies all this? Oh, it's the photoelectric effect, obviously.
Indeed.
This is exactly the photoelectric effect.
The experiment had already been done when this work was done by Schrödinger, so it was very easy to demonstrate that this solution was right. The experiment is very simple. You take a glass tube, you evacuate it, you fill it with a small amount of hydrogen.
No, it's a different one. Oh, you pass light through hydrogen?
And you pass an electric current through the tube. This makes the hydrogen glow. You pass the light that comes from that glow through a prism. Prism has the effect of splitting up the light into its constituent colors. Different frequencies go through the prism at different angles, and so the light is split up. When you do this with hydrogen, you find that you get 4 very different.
This is one of the things that I love about this channel, that he goes through experiments. He doesn't just shorthand. He goes through the details, the mechanical details of the relevant experiments.
Lines. One of them is red, one is green, one is blue, and one is violet. We know the frequencies of those 4 lines, and consequently we can calculate E equals hf, times constant times the frequency. And guess what? The red line precisely corresponds to the energy difference between n equals 3 and n equals 2. The green line precisely corresponds to the energy gap n equals 4 and n equals 2. The blue line precisely corresponds to the energy gap between n equals 5 and n equals 2. And the violet line precisely corresponds to the energy gap between n equals 6 and n equals 2. But I hear you say, what about an electron that falls down to n equals 1? Surely that would give off some photons as well. Why do we not see those in the spectrum of hydrogen? And the answer is that only the 4 jumps from n equals...
So it's ultraviolet?
6 to n equals 2, or 5 to 2, or 4 to 2, or 3 to 2 produce photons in the visible spectrum. Any jump to n equals 1 will be a much higher energy than that, and that means that it will be in the ultraviolet region. Similarly, any jumps at higher levels, for example from n equals 9 to n equals 8, will be very low energy level jumps, and they will be visible only in the infrared spectrum. We cannot see with our eyes ultraviolet or infrared, but if you get an ultraviolet detector or an infrared camera, then these lines become...
I would say there's much more energy here because the Coulomb's force is much greater here. Over here, the Coulomb's force is very weak. Yeah.
Visible. And so, the spectrum of the hydrogen gas gives us the proof that we need that the Schrödinger equation gives us a solution for the energies. And it also gives us the reason why electrons cannot spiral into the nucleus. They are constrained to operate in fixed energy levels. They cannot go into ones between. They cannot spiral. They can only move from one energy level to another, and that is by receiving energy at a particular frequency.
I wouldn't say that that's an explanation.
Or by giving off energy at a particular frequency. Finally, this explains the photoelectric effect. The photoelectric effect says that when you shine light onto a metal, you might get electrons coming off, but only if you shine light at or above a particular threshold frequency. And now we see the reason. If you shine light at a frequency between the ground state and the E equals 0 state, then the electron might bobble about a bit, but it won't leave. You have got to supply an energy, which of course is represented by HF, that's big enough to get the electron out of the atom.
Hello. Today we're going to look at the reason for quantum mechanics. I say that because I think a number of physics students think that the person who invented quantum mechanics did so just to annoy physics students down through the ages. In fact, quantum mechanics was developed to solve a very particular problem, and that's what we're going to cover today. Hello. Today we're going to look at the implications of the solution of the Schrödinger equation for the Today we're going to look at the
I'm just making sure that I marked all of these.
Hello. Today we are going to do Hello. Hello. Today we're going to look at the double and single slit experiments and diffraction gratings. Hello. Today we're going to look at wave functions, and in particular to understand why I chose the wave function that I did in my...
Okay, that's it. I think I'm gonna quit. Oh, wait. Who is Hanu? I don't know who you are. Yeah, I'm becoming very, very tired. Well, let's see what's going on here. Did it mention me? Suppress highlights. Let's see.
I think he might have gone away. Midwood has the best Bev impression.
That's true.
Like, literally, it sounds like Bev is
Do
joined back up.
Yui, do it.
Oh yeah, I hear you. Oh wow.
Yui.
I think he might have fallen asleep.
I can't. I'm in bed. I don't think I'll be able to do it on my phone.
Oh, come on. You've got it in you.
Your bed is flat, so you have to do it.
Yes.
You're in your flat bed.
It's horizontal.
It's a whole thing, you know. You gotta fuck yourself up for it.
Your bed is horizontal, and therefore it's the same as level.
I don't know. But it's like, Dan brings receipts. If you want to have an argument with...
Do you hang apples from your plums?
Well, I mean, it shouldn't be plum. It should be apple because apple is gravity.
It's called plum from the plum bob, and the plum bob used to be made of lead.
You mean a plum tree?
Plumbum.
Yeah, it's plum with a B, not plum like.
Oh, no, I think it's referring to a plum tree.
No, I think it's referring to lead.
Well, it wasn't a plum tree. It was an apple tree. Come on.
Yeah. You just hang the entire tree from a string, and that's how you determine up and down.
Exactly.
I think it's referring to
Has
lead.
to be.
Has to be.
Do you guys want to hear an
maybe we
interesting... Do you want to hear an interesting feeling that I'm getting?
Absolutely.
So you're wondering why do people like
I'm not really wondering.
become flat earthers? Like, what's motivating them to become flat earthers? And like, why don't they?
We know that
Really? What's the answer?
because they want to feel smart.
Because what? They want to feel smart?
90% of the flat earthers are flat earthers for social reasons.
Oh,
They want to feel smart.
wait. So you two have a disagreement. So which is it?
No, we don't. That's a social
I
reason.
think they're flat earthers because they lack the intellectual capability.
Nah, there's a lot of stupid people who are not flat
Well,
earthers.
then that means you would be a flat earther, NASA Shell. So we know that's
Ooh.
Shots fired.
Good one. Thank you.
I love you, NASA Shell.
It was
You missed that, Peter. You missed it. You missed Gamma absolutely destroys NASA Shell.
What was it? Oh, I'm testing my bot and I disconnected. What was it?
It's too late. You can't hear it now.
Yeah.
It was not bad.
Oh, he's gonna eventually do it again. So
Anyway, so I was thinking.
Slave, by the way, Midwit expanded on your paper. He added more arguments to the paper. It bloated the page count a little bit, but I don't think that's going to be a problem. You know, it's going to sound more scientifically correct when it's more.
Look, if they ask you about plagiarism, just say you don't know who that is.
Look, you guys are funny. It's okay. But I was just thinking, where should I go? Should I go to the Flat Earthers server, or
I
should
think
I?
you should go to Vienna or Berlin.
Or should I?
Show the flat earthers, go to 24/7 in politics and show them your updated document.
I think you should go to jail. You should go directly to jail. Do not cross code. Do not collect $200.
This is the longest citation I've ever seen in a scientific paper.
I think if you go to Ether Cosmology, man, they'll let you back in. They'll love that shit.
Anyway, so I was thinking, where
It's
should I?
still loading in my browser.
Yeah.
I mean, it has to be thorough.
Wait, let me just finish the thought. So I was thinking, where should I go? Should I go to spend time with, because I want to go to sleep. So just before I go to sleep, should I go talk to the flat earthers or should I go talk to the globe gangsters?
You're talking to the globe gangsters.
Talk to us.
Yes, I was thinking, and my intuition was, well, I can join the globe gangsters, but it's all going to be just making fun. I mean, they're making fun. They're mocking me at the end of the day. So I could go and
absolutely. You should go and ask the flat earthers.
1 second. Let me just say something.
I think you're proving my point. If you go there, you're going to feel smart.
Hold on. So I was thinking, where should I go? I can join the globe gangsters, but that's all. Just they're going to just continue mocking me, or I can go to the flat earthers and have a conversation. Like everybody's at least I would say honest. At least everybody's open minded. They might be out there. They might I agree that like they don't make any sense, but at least the conversation is honest. They're having an honest conversation. You guys.
Well, okay, hold on there. Like, is it honest if I lie to you and say I'm open-minded?
Look, I'd rather
There's no point speaking to a flat earther.
Look, when I speak to a flat earther, he's basically never joking. When I speak to a globe gangster, he's never doing anything but joking. There's not.
So I want to point out that when we first talked, when Mord once summoned me to talk to you, I 100% engaged with you in good faith.
Yes.
And I'm not really a big fan of people just making fun of you, although I'm not.
There is plenty of subject matter.
Yeah, well, be that as it may. Okay.
Mm-hmm.
I think that you can acknowledge that at very least that interaction was in good faith.
Right.
I did try to.
Yes. But
Okay.
this server. See, Sabine Horsenfelder, she wrote a book lost in math, and she has a video. In the video, she says that her grandmother used to say, be careful of large groups of people, because it doesn't matter how smart they are. In large groups, they will be dumb. And she says that, that basically physicists, when they gather in large groups, they start believing in the nonsense of string theory. That's her thesis. But it's very deep.
Nobody believes, not a single physicist believes in string theory.
Hold on.
That's not true.
That's not true. That's not true.
But let me
show me one
no.
physicist
Let me
who has.
finish. Let me just please. I have something deep to
Oh
say.
my God.
I'm sorry.
Even a Goldberg just told you that's not true. So
Look,
you're wrong.
it's
a little
you
bit
guys
limp.
you guys want, right? You're the globe gangsters. You want to fix the flat earthers. You want to take the flat earthers and teach them to stop the flat earthiness.
Wait, I thought we just wanted to have fun.
Well,
I thought it was a fun bit.
Well, that's fine. I mean, if you're just here to have fun, then that's fine. But if you are,
you said that.
It's up to you. Look, I'm just letting you know my insight, because I'm new here. I'm new to this universe, both to the flat Earth universe
Okay.
and to
All
you
right.
guys. And I was just before going to sleep, I just wanted to say goodbye, and I was thinking, where should I go? And I really didn't want to come back here. I really wanted to go to the flat earthers, because I feel so much more welcome with the flat earthers. And ultimately, I think that is what is driving the flat earthness. It's just that they're welcoming. They're just more welcoming. And you guys, as funny as you are, but it's
Well, Mr. Slave, right? I'll be absolutely honest, right? You
Mhm.
came into the call, right? You showed us your paper. We thought it was kind of funny.
I showed them. I also showed them.
But if you went to the flat earthers, this is the fun thing, right? They'll entertain your delusion, right? You don't want to do that, do you? You don't want your delusions entertained, do you?
I don't want to look. I want to. At the end of the day, I would rather be with them than with you. And
Yeah,
that.
okay,
that
I
is
get it. But like,
thing-
you do you want your delusions entertained, or do you want them to be challenged?
hold
Whether that be through
I
comedy
just spent.
or through
I left this room.
serious conversation.
I left
Wait,
this
hold
room.
on. Peter, are you ready to admit that you were wrong about the physicist? You said no physicist believes in string theory. Can you admit that you were?
Well, show me one.
I did in the side chat. I tagged you twice. Are you?
Anyway.
Okay, let me have a look.
Yep, go ahead.
I agree that there are.
Ew.
No,
So hey, wait. I want to address Mr. Slave. I don't. I agree that that people were not properly welcoming, and I didn't like that.
It's not. It's not that wouldn't.
Just
Well,
a minute.
it's not that. It's that he came in with a pay. He like.
Yes,
I'm not.
yes.
I am not in clown world right now, right? Where it's unwelcoming for us to say this paper is fucking stupid, right? I mean, like I don't. Do you want us to lie to him, Omnivore? Is that welcoming?
No.
Do you want us to say like, oh my god, it's so great.
Hang on. No. Okay. So I haven't figured out fully how I feel about this, but I believe that it's in good. I believe that it's in good faith, and I had the same reaction. And let me be clear: there is truth and there is brutality, and they're not the same thing. You can be honest without being mean. All right. Now, it was funny, and he was a pretty good sport about it. And I don't, but as somebody who has, done creative things, I wouldn't now, to be fair, I wouldn't claim to have created a theory of everything. That is, unfortunately, Mr. Slave, that's an extremely arrogant thing to do, which is not going to get you, it's not going to get you a kind of welcoming treatment unless you're dropping people's jaws, consistently. So, that's part of the problem. but you did come in here and you weren't an asshole about it like the ether guys are. And as far as I was concerned, I thought that counted for something, maybe a lot. So I'm not exactly sure what the response should be.
I would say like I was having a great time and laughing a lot, but I also am looking for at least a little bit of seriousness, and I could not get even the tiniest amount of seriousness out of the server. That is ridiculous, because I had to leave because I'm studying physics right now. I want to get actual feedback. I want to have a minimal conversation about something minimal. It's impossible on this server. It's a complete shit show.
Mr. Slave, you can DM me whenever you want, and I'll respond.
That's
You
fine.
could also do it the basic way, right? Rather than having us read this like absolute clownery of a paper, just make your argument in the VC and then hear a response.
I was trying. It was useless. But it's fine. Look. My point is, like, from now on, we're all going to be wiser about it. But part of it is, right, you're trying to understand, why is there a flat earth community in the 21st century? It's mind-boggling. So I'm telling you.
No, it isn't.
It's not.
We all fall to all sorts of aesthetics, identities and whatever.
What? I didn't understand what you just said.
There's all sorts of aesthetics and identities that people fall into.
Yeah, but why? So I'm
Because
telling
that's
you.
what people do.
It's not a rational thing. It's a lot of people
It
like,
is.
just
That's
reason
the-
away.
No.
No, it isn't. It's not something that people reason themselves into. Most of the time it takes a little bit of information to get into the idea, right? Whether it be Nazism, flat earth, Holocaust denial, and it takes a lot of reasoning to get them out, right? But that's not the point. It's not what we're not asking the question, how do you convert a flat earther? We're asking, why do they why do they exist, right? You don't need any great rationality to get yourself into flat earth. You just need a lot of aesthetics and identitarian based sort of motives.
Well, the idea of having a supportive, friendly community is a thing, right?
Exactly.
I mean, Dan says that a lot of people are doing it for social reasons, and I think he
Exactly.
would know.
Yeah.
So,
well,
let me just say this. Like, I think that the problem is you don't have. This is my honest feedback. No trolling. If you're being serious with this stuff, you don't seem to have the background that is required to make this work. And I think that there's a potential that application of an idea of ether to general relativity can make sense. But like, I have a paper right here that I guarantee you're not going to be able to understand. And until you understand that paper, I don't think you can make a meaningful contribution to the field. I mean, I don't necessarily discourage people from advancing this stuff, but like, that's my honest feedback.
That's actually a really good point. I think what you're going to run into. So, obviously, you're not dumb by any stretch, but the amount of
remains to be seen.
From the discussion I had about Compton scattering, it was it wasn't genius, but anyway, I thought he did well taking a look at it as a, but it is going to be, we do have
a waste of time. It's a waste of time, right? Let's be honest. You doing this is a waste of your time because nobody's going to take it seriously. It's going to be full of absolute. I mean, it's not even just the physics. You can't even write, so it's just a waste of time. Nobody's going to take it seriously. Just stick to regular debates. and stop making a fool of out of yourself, then maybe people won't laugh at you, right? That's should be a given. I mean, Omnivore's trying to be diplomatic, but sometimes you just need to hear the cold hard truth. This is like for children what you're doing right now.
Can I just add to this so he doesn't feel bad? Nobody in this room right now, and nobody who will ever show up in this VC is equipped to contribute to this field. Maybe Morty, if he moves his lazy ass and finishes the PhD in maths and then starts a PhD in physics, then maybe him. But other than that, nobody is equipped to contribute.
We had Tapioca Weasel, but yeah.
I don't care about the weasel. I don't know who that is, but I put my money that he's not equipped either. Otherwise, what is he doing here? What is he doing here then?
Yeah, because I invited him.
Wait 1 second.
Okay, well.
Wait 1 second. So
atomic physicist not going to contribute to the theory of relativity, is he?
Wait 1 second. Wait 1 second. So I spoke to. When you say
Did you parse the words that came out of my microphone?
You're talking to me?
Just spend some time. Yes, because you're high. So spend some time parsing those words. Or I'm going to spiral. I swear to you, I'm going to spiral.
You're going to spiral?
Yes.
What does that mean?
You're going to see.
It means he's going to get upset and go off.
Okay.
You don't want
Nobody wants that. Nobody wants that.
When people say like I mean, I'll describe it like bullying is sometimes necessary, right? It's not like we're not even being mean about it, but like you need some sort of social awareness and drilled into your brain that this is like it's never gonna happen.
Bullying. This is reality check. Nobody in this freaking VC can contribute to relativity at this moment.
Absolutely.
Nobody.
It's one thing if you were gonna like write a paper trying to like, I don't know, when you like write an undergrad paper, you try to understand basically what already exists. Maybe if you're doing that, then fair enough. But you're not adding anything new today, right? That's for sure.
Look, you might be correct. I don't know. But that's almost irrelevant to what I'm trying to say. What I'm trying to say is...
because you're a troll.
He's not free. Well, go ahead. Keep going. Don't interrupt him.
Okay. Look, what I'm trying to say is I had an honest thought before I came here, and I wanted to decide where to go. Should I go spend a few minutes with the flat earthers or with you? And I didn't want to come here because it's a waste of time to be here.
Yeah, but you don't get it, right? It's not that you are the problem, right? It's that this little fantasy that you're chasing is what we're laughing at, right? You yourself, if you started to debate like everyone else in a normal sort of way, where you type a few some shit in text chat and you say some shit in voice, then nobody would notice, right? You'd just be like anyone else. Probably say a bit of dumb shit here and there, but it's whatever, right? But the fact that you're asking us all to look at your paper, which is obviously garbage, right? And it will never be more than just that, right? And you're surprised that we're all laughing at it. I mean, it should at this stage be absolutely obvious that you should just drop the paper, right?
I'm not surprised.
Drop the whole shtick.
I'm not surprised that you're laughing at it. There is a limit, and you guys have. Like,
there's no limits to how funny that paper can get.
Look, at the end of the day, come on, at least a little.
Enough. It takes a physics student, a scholar of relativity, 10 years of study to fully comprehend general relativity. Have you spent 4 years studying general relativity?
No.
Then don't talk.
I'll do whatever
I hate to say
like.
it, but I think that might be the best advice that you can get out of this, which is that
that's irrelevant
that you're starting out with.
But that's irrelevant. Everything you're saying, I might agree or disagree. It's not really relevant. Look, this is the first time I'm having a serious conversation with you guys.
Yeah, because we're not talking about your paper anymore. We're talking about your actual idea, right? Of what, of like
look,
of what you're setting out to do.
Look,
Your
all I'm
paper's
saying,
funny,
it's
but
fine.
we're talking about your actual approach towards this
Everything.
entire sort of
Look,
debate, right? It's
I'm
just
just.
silly.
Look.
Yeah, I get the feedback. I get the feedback. It wasn't. It wasn't. I don't think that it was. You know, I didn't like how it went down. Personally.
Oh my god, Omnivore!
No.
Spare me this
Hey,
diplomacy.
No.
Like,
hey,
you're just trying to be nice. It's
No.
whatever.
You don't. I don't. I honestly don't care about the niceties. All I'm saying is, if you're wondering why flat earthers and other conspiracy theorists exist, that might be a simple answer. The fact is, I would rather spend time with any one of those than with you guys, because you guys are you're so brutal. You're just bullying and harassing and nothing.
Have you met a flat earther on Discord yet?
Yes, I spent some time on other servers.
Yeah, go to 24/7 and listen to those flat earthers.
You know, they might look. The point is, I spent time on another server. I'll tell you the name. The Earth Awakenings. I spent like an hour there. It was
Yeah, that's a better one.
okay. It was nothing but
24/7.
it was just an hour of productive conversation. No one was bullying. No one was harassing. No one was endlessly.
They're all schizophrenics over there. So.
It's fine, but I would rather be with them.
It's Mr. Slave.
Mr.
Hello.
Slave, you're not wrong there, mate.
Look, all I'm saying
I know
is
this guy.
all I'm saying
He's a
is
traveling debater.
all I'm saying is, like, you're wondering why conspiracy theorists exist. You're the reason. It's that simple.
Well, are you okay? No. We're not the reason they exist. We're the
Yes.
reason that, at best, that they don't stop being conspiracy theorists. Because
No,
nobody is convinced by someone they have beef with or an adversary of, right? So that's different. I don't think any of us made a flat earther in our lives, right? Flat earthers do their own thing. Then when they are flat earthers and they start to hate us, it becomes harder for them to stop being flat earthers. But that rests on the presupposition that any of us are interested in deconverting a flat earther, right? I mean, they'll come to their own mind when they're ready. There's nothing much we can do about it.
Okay. Anyway,
anyway,
yeah.
It's a good point. But yeah, I don't think. I think that I think it's a much more complicated issue than that. But yes, tell you what, if you go and hang out, so Earth Awakens is pretty good. But if you want to see the dark underbelly, go to Politics Server 24/7, and you'll get a, you'll get a different view of. You'll get the view of flat Earth that most of us have.
I've spoken before to other flat earthers. I never went to a complete all out flat earther server. The point is, they're nice, and you guys are.
Oh my god, you've not met the flat earthers we've met.
Okay.
Because
Yeah.
if you go to 24/7, right? Like, I was nice to flat earthers, right? I started out about a year ago, so not that long ago. And I went into this place called 24/7 Flat Earth and Politics, right? And I was very nice to them. They weren't nice to anyone else. You could be as nice as you want to be to them. That's not going to help you, right? These people made me the way I am, right? In the sense that, like, I have a lack of patience for them, and I think that the whatever's in their head is just a matter of what they want to be true, not so much based in any sort of empirical reality. But yeah, but when I say they're not nice, I mean, like, they mute a lot, they shout, they mock people.
They're not nice.
They make us look like angels. Let's put it that way.
Look, it's possible. I'm just letting you know. I'm just giving you my first impression.
Yeah, go speak to them.
Okay. Yeah, no, I think I okay. Well taken. I hear the feedback.
It's like it's okay to
I gotcha.
It's okay to bully. I was having a great time. Look, I have a I think I have a very, very thick skin. But at the end of the day, I don't want to
I don't know about that.
Yeah, at the end of the day,
you spent about an hour ranting about how we're mean to you.
No, I'm not. No, I'm not.
I think it's you got. I think he was a better sport about it than I would have been.
Look, I'm not even complaining. I'm still laughing. The point is, I don't want to
Yeah.
waste my time, and at a certain point, it becomes a waste of time.
Oh, okay. Listen, Mr. Slave. If your goal is in this VC to try to convince us that your paper's worth taking, hold on, I'm not finished. If your goal is to convince us that hold on, I'm not finished. You're going to understand what I'm going to say when I finish, right?
Okay.
If your goal is for us to take your paper seriously, that's not going to happen, right? If your goal is to speak to us about your ideas, right, just verbally, right, you might get some serious responses, right? It's just the only reason, right, that you're mocked in this VC is because of the paper.
That's
right?
fine. That's fine. I'm not even complaining. Everything is fine.
Yeah, okay, I got it. Yeah, no, but he's right. He's right. If you want to talk about the ideas without the, whatever the paper, I think you might find that.
Look,
to be more.
Right. All I'm
productive.
saying, everything is fine. Just a little bit less of pure making fun. Like, just take a break once in a while. Take a breath and say something not funny. Like, speak to me instead of like joking, endless joking. It becomes boring at one point. It's like it's boring.
Okay.
Like, you have to balance laughing with a little bit of seriousness. Just
All right, let's cut to the chase. What do you want to say, like outside of all this mess?
no. Altogether, I mean, I'm. That's it. I said everything. What do you mean, cut the chase?
All right,
I've been
brilliant.
cutting the
Okay,
chase.
anyway.
Well, hey, you're welcome back here. If you decide you want to come back, you're welcome. I welcome you back.
Yeah,
So,
I enjoy
don't,
being here. No, I
don't
enjoy.
sweat it. Yeah.
Yeah.
All right.
All right, I'm gonna go. Bye.
Okay.
See you.
Yeah.
Let's go say goodbye to the flat earthers.
In 2024. What about back in 1960,
Well,
1970, 1980?
The real like the most plausible explanation is that it's not going to set. It'll depend on what happens, but
Well, there can be no excuse for that material not being available at a touch of a finger on a click on a device. Okay, there is no excuse.
Hey, what are you guys talking about?
Sorry, I was just talking about the availability of material of the 24-hour sun supposedly orbiting the South Pole from the 1950s, 60s, 70s, 80s, 90s. Where's that material? And why are we squabbling about it now? It shouldn't be, the evidence shouldn't be relied upon 2024. This should have been done and dusted years ago and documented. National Geographic failed to document it, which is very odd because they documented the North Pole. They've documented the moon landings, which were a hoax. They've documented Everest and those who have triumphed and climbed it and got to the summit. You understand what I'm saying? They've done a lot of work dealing with Earth.
Wait.
And they didn't do the South Pole, where most of the action is.
Wait, can I ask a question?
Yeah, you go ahead.
Right, so each and every one of us is probably in a different time zone right now. Like, for some of us, it's midnight. For others, it's midday. Right?
Correct.
Doesn't that refute flat Earth?
Yeah. No, it doesn't. Why would it do that? The sun doesn't dictate a shape. You're going wrong again. Okay.
Wait, but for some of us it's midnight, for others it's midday. Like, for some of us the sun is at this angle, for others it's at that angle. We can all take a snapshot of the sun at the same time. We'll see it's at a different angle.
Okay, let me give you another scenario. Then. What's his name? D. Marble back in 2016 totally debunked the globe in 5 minutes. He was contacting his friends around the world via Skype. He's in Washington, D.C., Tromona or somewhere like that. The sun is above his head. We could see it. Then he contacts a guy in England, and it's 9 o'clock, and the sun is just disappearing on the horizon. And then at 6 o'clock, it's Australia. Good morning. He's just seeing the sun. Good morning. 3 locations. And then when we extrapolate that onto or transfer that onto the globe, and we get England and America lined up, Australia's in the dark. Okay, so like I said, you can't look at the sun and start denoting shapes. What goes on? Yeah, that's just never going to work. That's not logical. What is logical is to measure the 8 inches per mile squared on the surface you are on, which is conveniently under your feet. Do you understand that?
No,
That is the gold standard.
Wait. You're saying that you did one test and then you looked at the globe and it didn't work out?
Yeah, they transferred the times, okay, onto the globe, and Australia was in the dark. In reality, they could see the sun. Obviously, welcome to flat Earth.
I mean, did you run 5 minutes? Did you run a simulation of a globe and the sun? Did you run a simulation and see that there's a contradiction? How do you know who's right?
It was you could see them do that. You could see D Marble do it, and that experiment anyone can do. Perfect. Anyone could do it. You could do it. A child of 8 could do it.
I mean, has anyone done it? And can I see the experiment? Is there a simulation? Is there a YouTube video?
If you give me some moments, I'll post the video so you can watch it for yourself. Yeah.
Sure.
Yeah. But like I said, when you're not measuring curvature on the surface of the Earth, welcome to flat Earth.
When you're not measuring curvature of the Earth, then welcome to flat Earth.
No curvature measurements. We're not measuring curvature with today's latest cutting-edge technologies, ladies and gentlemen, in the in the Rumble live stream. Okay, we are using today's modern-day technologies, and we are not able to find a single degree of curvature. Nail in the globe's coffin is the aeroplanes definitely destroy the globe, and the latest video we have from Quantum Eraser called
wait.
The Globe Tiles Flatline proves flat Earth.
Wait, why? But let's go through one at a time. I mean, you said somebody can.
I'm just giving you what I know. That's all.
Wait, but we need to go through one piece of evidence at a time. Well, even one would be enough. You don't need to present so many evidences. One is enough. So.
Well, no, we do. Actually, we do. We do need to do that.
Not for me. I mean, if you, for me, why? If you can convince me with even one evidence, I'm convinced. I mean, if you can prove to me that the Earth is flat, the Earth is flat.
That's up to you anyway.
What?
Yeah, that'll be up to you whether you're convinced or not. That'll be up to you. But
no, so there's no point in presenting more and more evidence before I dealt with the first one. What's the point? I need to deal with the first one.
That's not what I find, you see. That's not what I find, you see, because I've been in this 9 years now, coming up for 10 years. The people I have met and introduced, it's not one thing that gets them to switch on. Sometimes it's a different avenue. So I have, myriad of avenues that I approach them with, and then suddenly one thing makes sense, and then all the others fall into place. So that's what it's like with some people that I've met. Some people, one is enough and they've got it. Other people take 3, 4, 5, half a year later, now they get it. Okay? That's been my experience.
So you said you're going to post a video?
Yes, I'm going to do that. I'm actually in the middle of retrieving it from my smartphone. So please give me about 2 minutes to actually get it. Got to scroll down. I know exactly where it is. I'm just going to get it whilst we're talking, okay? I had to reboot my phone, unfortunately. So that's what the hiccup was there. To apologize for the delay, but good things comes to those who wait, obviously. All right, so I'm now into my collection, my library.
Didn't the ancient Greeks figure out the Earth, the size of the Earth? Like they went to 2 different cities in Egypt at the same time, and in one place at the same time it was noon, but at the other place there was a shadow. and they calculated from equal triangles in the shadows the exact or near size of the sphere?
Well, you seem to be well informed, but then if you're that well informed, then you would know that if you replicate that same thing, but you bring, because he had to guess the location to the sun, but when you bring the sun closer to the earth, right, you get the exact same results.
Wait a
That's
minute.
why that's been debunked.
Wait, it was noon in both places, just that in one of them there was a shadow and the other one there was whatever. Here, like Carl Sagan went to this experiment. Let me show you.
Yeah, all he did was bend the card. That's what he did there. Basically,
Well, he
ladies and gentlemen,
explained.
he's talking about this name can be pronounced two ways. One is Eratosthenes or Eratosthenes. Either way, it's the Greek from 2,300 years ago. Supposedly, we don't know if he lived. We have no evidence, proof that he actually lived, but that's the story coming that he used some sticks, but they were actually obelisks, is actually what they were. But there you go. The story does evolve as time goes on.
So what's your...
And he measured that he somehow managed to measure the distance 500 miles and know what the sun was doing in Syene and Alexandria. These are the two locations.
Mhm.
How he knew what was going on simultaneously still eludes us there.
No, it was
But
noon. It was noon.
I'm nearly finished. I don't interrupt you when you have your spill. So allow me to have my spill. Thank you. Basically, when you bring the sun down closer to the earth, you can replicate the same thing on a flat earth, where that experiment, if it did happen, happened anyway, ladies and gentlemen. For we're not measuring curvature. And I'm nearly there now. 10 more seconds. It cannot be that we're living in the modern times and today's modern technology can't replicate what a man in a loincloth, battered sandals did. Finish. Go ahead.
Well, I don't get it. I mean, so you're saying if the Earth is flat, you can get the same results as if the Earth is curved? That's what you're saying?
That's exactly what we're saying, because we're bringing the sun closer to the surface of the earth, and the shadows are doing the same thing. That's exactly what I'm saying. Welcome to flat Earth, where we always were.
No, all you're saying is that this experiment is inconclusive. You're not proving flat
Debunked.
Earth.
Yeah, debunked. That I'm saying it's flat by default. It's the globe that has the burden of proof, and we're saying welcome to flat Earth. That's exactly what I'm saying. I'm not saying it's inconclusive. I'm saying it's without a doubt we're living on a flat Earth.
Wait.
Exactly
I don't
what
see.
I'm
I don't
saying.
see that. I mean, I see
Well, no,
inconclusive.
you wouldn't see that. You wouldn't see that, but I do. Okay.
Go explain.
I'm a flat earther.
Explain.
I was a heliocentrist for 48 years. I believed in the globe for 48 years, purely because I trusted the information I was given. So I didn't think it was necessary for me to check it. But now that I've checked it from 2015, I realized that was a 48-year belief right there. That was a mistake. That was an error. And Carl Sagan, as you call him, stated that a belief without confirmation or validation is a mistake. That's coming out of his own mouth.
Hold on.
Carl Sagan at the latter part of his life.
Wait 1 second. So what you're saying is that it's inconclusive, but now you're saying that it's not inconclusive.
I'm saying without a doubt it's a flat earth. That's what I'm telling you.
How?
That's without a doubt. Right?
Wait, but that's
well,
not
because of the measurements and this video that's coming up that I'm going to show you now. There is no evidence for a globe.
Wait a
Not
minute.
Not one proof of globe exists.
Wait a minute.
Not one.
You agree that it's inconclusive, right? You agree that the Carl Sagan...
I don't agree. I don't agree. I keep telling you, no, I don't. I do not agree. It's inconclusive.
Why not?
I'm telling you, it's a flat earth.
But you agree. You agree that. Hold on. You agree that there's two possible interpretations that are equal.
No, I don't agree. No, I don't.
So you're saying
no, I
that.
Do not, sir.
1 second. So you're saying.
Jin, you're saying that it's inconclusive, right? That if it's a globe or not, or what?
No, I'm just saying it's not a globe. It's a flat earth, without a doubt.
But
so you're saying it's inconclusive then?
Sorry, I've
I'm just
lost
messing
the
with you, Jin. I'm just messing with
Right.
you.
No,
I was
hold
gonna
on.
say,
Let me
right.
try and understand this, right? You agree that there's two interpretations to this experiment. Either the Earth is flat.
Oh, okay. Yes, yes. With the experiment, there are two. Yes. Yeah. Yeah.
So there's two.
Because what hang on. Let me just tell you what I'm saying. The experiment originally was conducted on a flat Earth, but the
How do you
story
know?
was it proved that because we're living on a flat Earth now.
How do you know?
Now, I know that.
How?
Evidence, no curvature.
How do you
No
know?
curvature.
How do you know?
I know because I've
How?
measured it. I've measured it myself.
But look, this experiment we're discussing right now, you agree that it has two interpretations.
It's originally was done on a flat Earth.
How do you know?
Can someone tell me the experiment, please?
Watch the video.
Aristophanes, Eratosthenes.
I put the video on the side chat. The Carl Sagan video.
Wait. No, both of you guys, just wait. Eratosthenes, that's what you guys are talking about?
Yes.
Is sticks and shadows or the sunlight down a well?
Yes.
Something like that?
That's
you
right.
have to assume you know what the sun is and where it is and how big it is.
Thank you.
No, you don't
That's
have
exactly
to.
what I'm saying to you.
Look, the way I understand it, there's two
You have to
interpretations.
assume the medium in between you and
You
the
have
sun. Yeah, you gotta do that too.
No, there's two interpretations. Either the Earth is a sphere or it's
No, you
flat.
have no, you have to make assumptions in either case, my friend.
Right, fine. There's two interpretations.
So I would call it a false dichotomy. Google that real quick, like.
I know the word's false dichotomy. What do you mean there's a false dichotomy?
Means it's not either of them. It could be something else.
So the Earth is not
You going
flat?
concave?
We're saying it's
You
either
going concave on this, right? Come on. You know I've been around long enough. Looking at the sun and telling me what the ground is fucking ridiculous, and you know it.
Exactly what I said 10 minutes ago.
So you're saying that the interpretation that the Earth is a sphere is incorrect, is not possible? There's a contradiction.
By looking at the sun, no, it is not.
Absolutely incorrect.
How old are you, guy?
Wait,
you still in high school?
1 second. You're saying that
Yeah, answer my question.
Why? It's not relevant.
Yeah, it's not relevant.
Well, it is.
No, it's not.
It is relevant.
No. So you're saying that the Earth.
It is relevant. You don't have the life experience yet to have a human intellectual conversation because you keep saying that we have to agree to something. No, man, we don't.
Okay, so you're referencing me, and that's an ad hominem. So that's not an argument. It's a logical fallacy.
I'm not trying to make an argument, sir.
Well,
I'm trying to have an intellectual conversation. Do you want to start there?
Okay.
Let's just stick to the point.
Yeah.
What do you think? So
Yes. He thinks Eratosthenes has proven that the Earth is a sphere, right, guy?
No, I didn't say that.
Mr. Slave.
No, I didn't say that. I said it is a possible interpretation of the data of the experiment. It's a possible.
Sure, I'll agree to that. Yes, I'll agree to that if you assume that you know how far away and how big the sun is.
No, you can assume it's at.
There's way more assumptions than that.
It
No,
doesn't
I know,
matter.
but let's start with
Fine.
that.
Look,
Let's start with that.
You can look. One interpretation of this experiment is basically as big physics explains. Another interpretation of this experiment is flat Earth. Right? There's two possible interpretations that are equal but different. But there's no there's no preferred.
Okay.
There's no preferred interpretation. They're
I would
equally
say
valid.
that
Right. Okay,
false
fine.
dichotomy
It's
right
a
there.
false dichotomy. Right there. On its
Dichotomy,
face.
what do you mean, sir?
I'm not.
You just agreed to it.
Who wait.
It is a dichotomy.
Rob, your
and
mic
I-
is a little
Let me just turn my
Your
Bluetooth
mic's
off.
a little.
Yeah, give me a second.
Yeah, it's a clear dichotomy. I mean, either it's a sphere or it's a flat Earth. But it's two separate interpretations.
Just hold on a second. Hold on a second, please. I've posted the video. I've posted the 5-minute video that you need to watch.
Where?
By D Marble. It's there. You can see it.
Where?
It's in there. It's in the chat.
Where?
Is that any better?
Sure.
Could you put it in the
It's in the
side chat?
Slightly.
The live stream text. The live stream's text. That's
Okay,
where it's
got
at.
it. Got it. Okay.
Okay. Jin CBR1. Flat Earth T-shirt. And then we got my brother there, D Marble, debunking the globe in 5 minutes. Okay? And I tell you, that's just a quick slam dunk right there.
Anyway, so right now
Australia was in the dark.
I'll take a look at it after. So right now we're saying that there's two equally valid interpretations of the Carl Sagan video. One is, as Big Physics says, that the Earth is a sphere and the sun is, far away. The other one is that the Earth is flat and the sun is whatever. So, right, these are equally valid interpretations. Am I correct?
The sun is whatever.
Whatever flat earthers want to say. It's like there's two interpretations. One is, as Big Physics, Earth is a sphere, but the other one is flat Earth. Right? These are two. These are.
Yes. Can we?
I feel like this is the false dichotomy part. Hold on, Rob.
Sorry, man.
I feel
Okay,
like this
go
is the
ahead.
false dichotomy part. I feel like this is the false dichotomy part. I wonder what a concave earther would say about Eratosthenes. I've never heard him.
Wait, before we go to the concave, let's just discuss the flat Earth. So, what we're seeing is that flat Earth is an equally valid interpretation of the data as the Big Physics spherical Earth, right? There's no preferred interpretation. They're both equally valid.
I think what you've got wrong
After the massive amount of assumptions you have to go through with Eratosthenes, you can make it be anything. So I don't know.
All I see is two interpretations. One is Big Physics sphere, and the other one is flat Earth. What's the third?
Here's the assumptions you have to go through before you can come to any conclusions with Eratosthenes. You have to know the whole medium between you and the sun. There's one assumption that you have to get over.
What do you
Another
mean?
assumption would be
What do you mean?
You have to assume the medium in between you and the sun.
I don't know what you mean. What do you mean? I honestly
There's
don't
a
know.
medium between us and the sun, and you have to assume something, because obviously if you have some kind of lens in between us and the sun, then that would change everything about the results.
A lens?
A lens.
I'm not.
Yeah, you know what a lens is, right? You know what a lens is.
But I'm not following your line. I'm not following your line of thought. So there's two interpretations.
No shit.
So there's two interpretations. There's Earth is a Big Physics sphere, and the flat Earth interpretation.
How many times are you going to tell us there are two interpretations? We agreed to that.
Okay.
Can we move on from that?
Okay, stop.
I don't even
getting
agree to
upset.
that, but
So there's two.
alright, if you want to.
As far as I understand, I can see two interpretations, and I don't see one of them being more valid.
How many interpretations?
I can't hear you. So I don't see either one being a preferred interpretation. They're equally valid, right?
Right. No, not really, no, because one is based in fantasy, the other one is based in reality. That's the difference. That's what you don't seem to understand.
It's just two
Aristophanes. I'm still talking, man. Aristophanes, we don't know if he lived. You have to assume the medium that you're in. You have to assume the distance to the sun. You have to also now assume that he knew what he was talking about between Syene and Alexandria, and he knew what was going on 500 miles apart. There's a lot of assumptions going on right there. That would be live physics, not big physics. Sorry.
but fine. But at
Real
the end,
physics is the flat Earth. Real physics is the flat Earth. Real physics.
at the end of the day,
Horizontal.
there's two interpretations with many assumptions or with few assumptions. There's two interpretations.
There's only one real one, and that's the flat Earth, as it is. The other one, which is the Aristosthenes, is an assumption. It is not based in reality, and we can't prove whether or not the guy lived. There's a lot of assumptions. So that makes
either way, if the guy lived or not, it's kind of irrelevant. We know the test now.
Yeah. So I just don't understand why you don't agree that these are two equally valid interpretations.
Yeah, they're not, because the Earth isn't a globe. The Earth isn't a globe. It doesn't measure as a globe. That's why they're not equal interpretations. They're
Well,
not.
we don't know
One
that,
is
right?
based. I do know that.
How do you
I
know?
do know that.
I
Not
don't
telling you
know.
what I know, and I don't.
I don't
Of course
know.
I know that.
I
you don't know that. That's your
exactly.
problem.
Exactly.
Not me.
Well,
Yeah, your problem.
so
Thank
you
Gentlemen,
agree.
gentlemen,
Then you
this
agree.
individual doesn't know what he's
Then
talking
you
about.
then
So
you
he has to have that.
one second.
Guys, hold on, man. We got to go one at a time. Jin, everyone, guys, relax.
Okay,
Please.
yeah. So you agree that as far as I'm concerned, there's two interpretations that are equally valid. This Earth is a sphere and Earth is flat, right? You agree that as far as I'm concerned, they're equally valid.
I cannot agree with you, sir. I cannot and will not be agreeing. Thank you.
Go on. Why not?
For the third time, one is based in reality, which is the flat Earth, and the globe. Aristosthenes is based in a fantasy.
But you
That's the
look,
problem.
as far as I'm
All
concerned,
assumptions.
as far
They're
as
not
I'm
the same.
fine.
Integrity is lost. One doesn't.
You're breaking up. You're not completing your sentence. You're completely broken up. You check your audio, your
You
mic.
just spit out your point with Eratosthenes so we can get this over with. So, what's the point?
Who? Me?
You get some Eratosthenes point here.
All I'm saying is that
two equally valid.
Yeah, that's all I'm saying. As far as I'm concerned, the Earth could be a sphere. It could be flat based on the Carl Sagan experiment. It's inconclusive. There's no reason to prefer flat Earth over spherical Earth or vice versa. That's all I'm saying.
I would agree. Eratosthenes doesn't prove jack shit. I agree. I don't know. That was your whole point. Why were you guys even fighting him on that?
I wasn't fighting.
I was talking to these other guys. I don't know why they were even fighting you on that. I 100%
No,
agree.
that's exactly what I was trying to say. Why are you guys even trying to say that it proves anything? It doesn't. That's what I thought.
Get it together, Rob.
I'm sorry. It's Friday night. I get excited.
You know, a little Canadian mist in you? A little Hindu Kush?
Yeah.
Diminishing returns, that's called.
Yeah, so I'm kind of wondering on like the geometry of like the atmosphere on the globe. The geometry is going to be.
Well, wouldn't there be an atmosphere
And-
cave on the concave?
And the winds as they go further and further out. In the concave version, it'll have a contribution.
My God, it's endless, and these people think, oh my God, this is such a complete waste of time. Okay, I'm gonna watch just a little bit more of this video. I've been here for 3 hours. Just a little bit more of this.
Video on the Schrödinger wave.
Oh, we've done this. We've done the solving. What are we up to? We're up to the reason. I think I've already watched the reason for quantum
Today we're going to look at the
mechanics.
reason for quantum mechanics. I say that because I think a number of physics students think that the person who invented quantum mechanics did so just to annoy physics students down through the ages.
Yeah, I think I already listened to it and the next 3. Introduction to quantum mechanics.
Hello. Today we're going to look at the basic introduction to quantum mechanics. In my video on the reason for quantum mechanics, I explained that light, which had always been thought of as a wave, could also be regarded as made up of particles, or photons. This led physicists to wonder whether particles might behave like waves, and in particular whether an electron in an atom could be...
This is completely incorrect. It's not a dot. It's not a particle. It's still a wave, but it's just it's a wave with momentum, and I mean, it's still a wave. It's still the waving of the ether. There is no particle moving. There is a wave moving through the ether, no matter how you look at it.
Be regarded in this way. It turned out that this was the way of explaining why electrons do not spiral into the nucleus and annihilate the atom.
I don't see how that explains it.
In my video on the wave function, I showed why it was useful to choose a wave equation to describe the electron of the following form.
No, you didn't.
Psi equals e to the I kx, which also equals...
You never explained why it's a good form.
Cosine kx plus I sine kx.
Yeah, you never explained why the cosine is not as good as the e to the I. What's wrong with just the cosine?
K equals 2 pi over lambda, where lambda is the wavelength of the wave. P equals h, which is Planck's constant, over lambda. That's the de Broglie equation, which is set out in more detail in my video on reasons for quantum mechanics. So P equals k h bar, and h bar is h over 2 pi. You might wonder why we do not use a simpler wave function of the form psi equals cosine kx. The reason has to do with the uncertainty principle, or Heisenberg's uncertainty principle, which I explain in more detail in another video, but which essentially says that you cannot measure the position of a particle and its momentum at the same time. This principle is often expressed as delta x, delta p, which is the uncertainty in position multiplied by the uncertainty in momentum, is greater than or equal to h bar over 2. A postulate of quantum mechanics, which is one we will come to shortly, says that the probability of finding the electron at any given point in space is equal to the square of the wave function at that point. If we consider psi equals cosine kx, then...
But what is the evidence? What is the evidence for this claim? Has this been ratified by experiments?
Since k equals p over h bar, psi equals cosine p over h bar times x. But this implies that we know both p and x, that's momentum and position, precisely. And Heisenberg's principle says that we cannot do that. If we know p precisely, then we cannot know x at all. This means that psi squared, which represents the probability of finding the electron at any point, must be a constant, since the probability will be the same for any point in space. But for psi equals cosine kx, psi squared is cosine squared kx, which is not a constant. So cosine kx cannot represent a wave function.
1 second. Let's see what's going on. This is a very interesting argument.
Function of the electron. But psi equals e to the I kx does the job nicely. But in order to show how, we first need to look at how we deal with complex numbers. We can plot the wave function on a complex plane. We plot the imaginary term along the vertical axis and the real term along the horizontal.
So finally, he's giving the reason why he's using the complex notation for the wave function.
Axis. E to the I kx equals cosine kx plus I sine kx. The sine kx term is the imaginary term and is plotted on the vertical axis. The cosine kx term is the real term and is plotted on the horizontal axis. The length of the vector, which is psi, since the length of psi is equal to cosine kx plus I sine kx, is such that psi squared represents our probability term for finding the electron at any given point. Psi squared can be found by Pythagoras. Psi squared equals cosine squared kx plus sine squared kx, and that equals 1. If we want the wave to have a different amplitude, we would need to use the term psi equals a times e to the I kx. Then the absolute length of the psi vector would be a, and the probability would be a squared. This satisfies the condition that the probability is a constant, and that we have no idea where the electron is if we know its momentum precisely. How can we get to this term mathematically? Squaring the wave function doesn't do it, because if psi equals a e to the ikx, then psi squared is a squared e to the I 2kx, which is certainly not a constant. But we can create a thing called a complex conjugate. The complex conjugate of any wave has the same real term, but change.
So far, I'm not following, but I'm going to watch it again. But I just want to see where he's going with this.
Is the sign of the imaginary term. So if psi equals a e to the ikx, which equals a into cosine kx plus I sine kx, then psi star equals a into cosine kx minus I sine kx, which can be written psi star equals a e to the minus I kx. And so we can see that psi.
This is the complex conjugate, okay? So psi times psi conjugate, psi star
equals a e to the ikx multiplied by a e to the minus ikx, which, since e to the ikx multiplied by e to the minus ikx is 1, is a squared, which is the constant we wanted. So for complex terms, the probability of finding an electron at a particular point is psi times psi star, in other words, the wave function times its complex conjugate. Consider an electron orbiting a nucleus. Instead of thinking of this as a simple orbit, we now need to think of the electron behaving like a wave. It will be a standing wave, which means that as the electron orbits the nucleus, the value of the wave function at any point does not change. In other words, if the wave function has a particular value at this point, then after the electron has completed one further orbit, the value of the wave function will be the same. Let us suppose that the length of the orbit is L.
Is this true? I don't think so. I mean, in a standing wave, it moves up and down, but it's not a standing wave. If it's a moving wave, then this point has to move around. Can't stay here. Either way, it can't stay there. I don't know what he's talking about.
Which is essentially the circumference of the orbit. This is 2 pi r, where r is the radius of the orbit. This means that the wave function at any point x is e to the ikx. After the electron has traveled one full orbit, it will now be at position.
If he doesn't add time, then he's taking a snapshot of the wave. That's why it's not moving. It's not to say that it's a standing wave. He's just taking a snapshot of a moving wave.
X plus L. The wave function will be e to the ikx plus L. But these two wave functions must be the same. So e to the ikx equals e to the ikx plus L, which is e to the ikx multiplied by e to the ikl. The e to the ikx term cancels out, leaving the requirement that e to the ikl equals 1. How can this be satisfied? It could be.
This thing is this thing. Which is equal to 1? IKL equals 1? Why?
To the ikx multiplied by e to the ikl. The e to the ikx term cancels out, leaving the requirement that e to the ikl equals 1.
Why?
The e to the
Why is it
ikx
equal
term
to
cancels
1?
out. So e to the ikx equals e to the ikx plus L.
But why is it 1?
Which is e to the ikx multiplied by e to the ik.
I think I understand.
L. The e to the ikx term cancels out, leaving the.
So that's 1. E to the IKL equals 1. Okay.
Requirement.
Because it's cancelled. Cancelled means 1. We're left over with 1. E to the IKL is 1.
E to the ikl equals 1. How can this be satisfied? It could be satisfied if k or l equals 0, but then the solution would be trivial. It can also be satisfied.
Wait, we watched this before, didn't we?
If kl equals 2 pi, or any multiple of 2 pi. But l was 2 pi r, so k 2 pi r equals n 2 pi. But
so k times l is k 2 pi r, which is equal to n 2 pi.
K equals p over h bar, so p times r.
K is p over h bar.
Is n h bar. P times r.
So it's p 2 pi r over h bar. Wait, you have pi on both sides. Pi goes away. Anyway, what is he saying?
Is angular momentum.
Oh, we've been through this. We've been through the angular momentum.
And that must come in discrete units of h bar, since n must be a whole number.
But how is this related to the complex solution?
This is the first major consequence of quantum mechanics. Momentum and angular momentum are both quantized. They cannot just take on any value. They must be in discrete units of h bar. So
how is this Heisenberg? Didn't he start with Heisenberg?
when momentum changes, it must do so in set units of h bar. There is no such thing as continuous change in momentum. It is jerky. Since h bar is about 10 to the minus 34, we don't see its effects in the world about us, but it's there all the same, and has a much greater impact in the world of the atom and the nucleus. Hello, today we're going to solve the Schrodinger equation for a free particle and a particle in a box. We start off with the time-independent Schrodinger equation, minus h bar squared over 2m. Hello, today we're going to solve the Schrodinger equation. Hello, today we're going to solve the Schrodinger equation. Hello. Hello, today we're going to look at the basic introduction to quantum mechanics. In my video on the reason for quantum mechanics, I explained that light, which had always been thought of as a wave, could also be regarded as made up of particles or photons.
Yeah, okay, we need to take a break. All right, I'm gonna stop here. What's 5? Why do I keep getting notifications? Are they referencing me? I don't get it. Why isn't it scrolling all the way down? Let me see. I don't know. I'm just trying to get rid of the notifications. I don't know what to do. How do I get rid of I don't want to get notifications. Didn't I tell the server notification only mentions suppress, mute, mobile push? Well, I want mobile push, but only, forget it. Okay, I'm out. Bye.